about networking, both basic skills such as identifying various types of networks and more advanced skills such as installing a network and solving any problems that prevent the proper functioning of your network. We have 5 labs where you can build on your networking skills. Click on a door to enter the lab. Welcome to the Networking Introduction Lab. Here, you will learn more about the fundamentals of networking. Click on a topic on the screen to continue. A network is an interconnection of computers, workstations, and peripherals. It facilitates the transfer of information and sharing of resources between a number of users. These resources include peripheral devices such as printers, scanners. Networks can be categorized as per the geographical area that they cover. The different types of networks are local area network, that is LAN, campus area network, that is CAN, metropolitan area network, that is MAN, wide area network, that is WAN. Click Next to continue. In this lesson, you will be able to explain the history of computer networks, that is ARPANET. Explain the need of networks. Explain types of computer networks. Explain layers of open system interconnection, that is OSI model. Explain network selection criteria. Explain standard organizations. Click Next to continue. A local area network, that is LAN, is a computer network that spans over a small area. It connects computers and workstations to share data and resources such as printers or faxes. LAN is restricted to a small area such as home, office, or college. Click Next to continue. Local area networks are classified on the basis on which data is transferred within the network. Click the images to learn more. Click Next to continue. A campus area network, that is CAN, is made up of 2 or more LANs within a limited area. It can cover many buildings in an area. The main feature of CAN is that all of the computers that are connected together have some relationship to each other. CAN is larger than a LAN but smaller than wide area network, that is WAN. Click Next to continue. A metropolitan area network, that is MAN, is an interconnection of networks in a city. MAN acts as a high-speed network to allow sharing resources within a city. It is formed by connecting remote LANs through telephone or radio links. The best example is the television cable network in cities. Click Next to continue. A wide area network covers a wide geographical area which includes multiple computers or LANs. It connects computers through public networks like telephone system, microwave, satellite link, or a leased line. Most of the WANs use leased lines for internet access as they provide faster data transfer. Click Next to continue. The Open System Interconnection, that is OSI model, is an internationally recognized set of standards developed by the International Standards Organization, that is ISO, for communication between computer systems. The OSI model is a conceptual model that has 7 layers. Each layer of the OSI model performs distinct functions on the data in accordance with the previous layer functions. The different layers of the OSI model are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Click Next to continue. Physical layer is the first or the bottommost layer of the OSI model. This layer is used to establish or terminate a connection to a communication medium. It also defines the electrical and mechanical specifications like cables, connectors, and signaling options of the medium. Physical layer receives data from the upper layer called the data link layer. It converts the received data into bit stream. The data is then transmitted through the medium to the receiver. At the receiving end, physical layer receives the data in bit format. It forwards the data to the data link layer. The responsibilities of the physical layer are media characteristics. It defines the characteristics of the interface that is used for connecting the devices. Encoding. It defines the type of encoding being used. Transmission rate. It defines the transmission rate of bits. Defines the transmission mode between two devices. The transmission mode specifies the direction of signal flow. Defines the way in which devices are connected to the appropriate link. Defines how the devices are connected to form a network. Click Next to continue. Data link layer handles data transfer between the network and physical layers. It receives data from the network layer, adds a header and trailer to the data, and passes data to the physical layer. At the receiver, it receives data from the physical layer, removes the header and trailer, and passes the data to the network layer. The responsibilities of the data link layer are framing. It organizes the bits into data units called frames. Physical addressing. It adds header to the frame which contains the physical address of the sender and/or receiver. Access control. It provides access to the link to a single device. Flow control. It synchronizes the rate of transmission between two nodes. Error control. If a frame is corrupted, the data link layer retransmits it. It also prevents frame duplication. This is accomplished using the trailer. Click Next to continue. Network layer is the third layer of the OSI model. The data unit at this layer is known as a packet. The network layer is not needed if the two communicating devices lie on the same network. However, when the two devices are on different networks, network layer is essential for the source to destination delivery of packets. The network layer receives data from the transport layer. It adds a header to the data and passes data to the data link layer. At the receiver side, network layer receives data from data link layer. It detaches the header from the data and passes data to the transport layer. The responsibilities of the network layer are logical addressing. It adds header to the data that includes the logical address, that is, IP address, of the source and destination. Routing. It defines a proper route for the packets to reach the destination. Routing can be of two types, static or dynamic. Handling congestion issues. It is the responsibility of the network layer to control any congestion problems that may result due to excess traffic. Internetworking. It keeps a check on the interconnectivity of different networks. Internetworking means connecting two or more computer networks together. Click Next to continue. Transport layer is the fourth layer of the OSI model. The data unit at this layer is known as a segment. The transport layer ensures that the entire message reaches in order and handles error control and flow control at the source to destination level. Transport layer receives data from the session layer. It divides the data into segments and passes these segments to the network layer. At the receiver, it receives packets from the network layer. It detaches headers from them, reassembles the segments into the original message, and passes that message to the session layer. The responsibilities of the transport layer are service point addressing. It transfers data from a specific process on one computer to a specific process on another computer. Segmentation and reassembly. It reassembles the segments of the message at the receiver end. Connection control. It provides either connection-oriented or connection-less service. Flow control. It performs flow control, which takes place end-to-end. Error control. It also performs error checking, which takes place end-to-end. Segments are retransmitted to achieve error correction. Click Next to continue. Session layer is the fifth layer of the OSI model. This layer establishes, manages, synchronizes, and terminates connection between the computers. It also sets up, coordinates, and terminates interactions and dialogues between communicating devices. It provides either half-duplex or full-duplex service. Session layer receives data from the presentation layer. It adds a header and synchronization bits to the data and passes data to the transport layer. At the receiver side, session layer receives data from the transport layer. It detaches header and synchronization bits from the data and passes data to the presentation layer. The responsibilities of the session layer are: dialogue control. It sets up sessions between devices. Control is exercised by using a token. Only the user that has the token can send data. Synchronization. It synchronizes the sessions. Synchronization bits are added for this purpose. Click Next to continue. Presentation layer is the sixth layer of the OSI model. This layer deals with the syntax and semantics of the data exchanged between two devices. It transforms the data into a format that will be accepted by the application layer. Presentation layer receives data from application layer. It adds a header to the data and passes data to the session layer. At the receiver side, the presentation layer receives data from the session layer. It detaches the header from the data and passes data to the application layer. The responsibilities of the presentation layer are: translation. It handles interoperability between encoding systems used by different computer systems. Encryption. It adds security by encrypting data. At the receiver, it decrypts the data. Compression. It compresses data to save bandwidth. Click Next to continue. Application layer is the seventh layer of the OSI model. It provides a means for the user to access information on the network using an application. It also supports services such as electronic mail, remote file access, and transfer and shared database management. The services provided by the application layer are: Network Virtual Terminal. Using this service, a user can log on to a computer that is remotely connected on the network. File Transfer, Access and Management, that is FTAM. Using this service, a user can access and manage files in a remote host. Mail Services. Using this service, emails can be forwarded to another device. Message Handling System, that is MHS, is the OSI protocol used to transfer mail over the Internet. Directory Services. This service provides information about objects such as people, organizations, programs, and files. Click Next to continue. How many layers does the OSI model consist of? Select the correct answer and click Submit. That's right. The OSI model consists of 7 layers. Click Next to continue. A network is selected based on certain network criteria. During the network selection, it is important to consider these criteria for improving network functionality. These factors are: performance, reliability, security. Performance. The network should provide the desired performance. Organizations may need to upgrade their networks as per their requirements. Hence, it is important that the network should be flexible, not permanent. The network should be designed in such a way that it is possible to expand or upgrade it in the future. Reliability. The network must provide some degree of reliability. The reliability of a network is determined by how frequently the network fails and how much time it takes to recover from a failure. The network monitoring systems and network devices are necessary for making the network reliable. Security. The network must provide a certain degree of security. This is achieved by using antivirus software and firewalls to prevent unauthorized access to the network. Backup tools are used to safeguard important data. Click Next to continue. Standard organizations develop, maintain, improve, amend, and revise standards. They develop technical or non-technical standards. These organizations can be government or non-government organizations. Click the various boxes to learn about some organizations. Click Next to continue. In this lesson, you learnt that computer network enables the user to share data and network resources. Network allows remote users to communicate with each other. Computer networks are divided into LAN, CAN, MAN, and WAN. LAN is a small network and easy to create. OSI model has 7 layers and provides standards for communication. Physical layer is responsible for actual transmission over the medium. Data link layer is responsible for node-to-node delivery of frames. Click Next to continue. In this lesson, you learnt that network layer performs end-to-end delivery of packets and routing. Transport layer performs end-to-end delivery of the entire message. Session layer establishes, manages, and terminates sessions. Presentation layer performs translation, encryption, and data compression. Application layer provides access to the network resources. Standard organizations develop technical and non-technical standards. Click Next to take a quiz. Welcome to the Networking Introduction Lab. Here, you will learn more about the fundamentals of networking. Click on a topic on the screen to continue. A network is an interconnection of computers, workstations, and peripherals. In this lesson, in single bus topology is a network topology in which a network is an interconnection of computers, workstations, and Welcome to the Networking Introduction Lab. Here, you will learn more about the fundamentals of networking. Click on a topic on the screen to continue. A network is an interconnection of computers, workstations, and peripherals. It facilitates the transfer of information and sharing of resources between a number of users. The topology of a network refers to the arrangement of different devices of the network. Topologies can be physical or logical. Physical topology refers to the actual physical structure of the network, while logical topology refers to the way in which the data transfer takes place in the network. The types of topologies are single node, bus, star, ring, mesh, tree, hybrid. Click Next to continue. In this lesson, you will be able to explain the different topologies. Explain the structure of various topologies. Compare different topologies. Click Next to continue. In single-node topology, the server or host is having all the information for the network. The terminal, sometimes called a dumb terminal, does not contain necessary files to function independently, is connected to the server. Generally, the host is larger, that is, mini-computer to mainframe, and capable of serving a host of terminals. A single-node network consists of a single device attached to a server. If the device does not have any files, it is called a dumb terminal. This terminal will access the files from the server process them, and return them back. Terminals, other than the dumb terminals, use the server for backing up files or using its printer. Advantages: easy to install, configure, and manage. Least expensive. Single cable is required. Disadvantages: only a single device is connected in the entire network. Dumb terminal is dependent on the server for resources. Click Next to continue. Bus topology is a network topology in which all devices are connected to a common backbone cable with terminators at each end. This topology uses the daisy chain scheme to connect the devices. In this scheme, device 1 is connected to device 2, device 2 is connected to device 3, and so on. The network data is sent to all the devices along the cable. As the message arrives at each device, it checks the destination address, which is encoded in the message. If the address matches, it accepts the data. Else, it ignores the data. At a time, only one device can send data. If a device fails, it does not affect the entire network. However, in an active topology, devices regenerate the data. Hence, if a device fails, then the entire network is affected. If two devices transmit data simultaneously, the signals may collide and the data gets destroyed. Advantages: easy to design, install, and maintain. Requires less cable as compared to star topology. Less expensive than other topologies. Works better for smaller networks. Disadvantages: entire network gets affected if there is a break in the main cable. Terminators are required at both ends. Difficult to detect a faulty device. Limited number of devices can be attached. Sharing same cable slows down the response of the devices. Expensive than single node topology. Click Next to continue. A star topology is designed in the shape of a star. All devices are connected to one central point known as a hub or a switch by using either copper cables or fiber optic cables. This topology provides a cost-effective method for sharing information between different users. The hub manages and controls all the functions of the network. It can be passive or active. A passive hub simply routes the traffic to all devices. They do not regenerate the signals. An active hub regenerates the signals and retransmits them. Also, it repairs a data packet if it is damaged. The data has to pass through the hub before it can reach its destination. For example, if device 1 wants to transmit data to device 2, it first sends the data to the hub. The hub will broadcast the data to all devices on the network. Advantages: easy to install, configure, and maintain. Easy to detect faulty devices. Easier to expand. Connecting or removing devices does not affect the network. Hub provides a centralized management. Disadvantages: increase in number of devices generates traffic which makes the network slow. Requires more cable than linear topology. Hub failure leads to network failure. More expensive. Click Next to continue. In ring topology, each device is connected to the adjacent device, forming a circle. Data flows in only one direction, either clockwise or anti-clockwise. Each device in the ring topology acts as a repeater. It regenerates the signals and retransmits them to the next device. The data has to travel through multiple nodes before reaching its destination, which makes it inefficient compared to a star network. For example, if device 1 wants to transmit data to device 3, the data will travel from device 1 to device 3 via device 2. Hence, inefficiency increases with the increase in the number of devices. Sometimes, a second ring is added to the network. This network is called the dual ring network. The primary ring carries data in one direction and the secondary ring carries data in the opposite direction. Both rings are independent of each other. The secondary ring is used only when the primary ring fails. Advantages: easier to manage as compared to bus topology, handles large volume of traffic, reliable and offers great speed, suitable for long-distance communication. No terminators are required. Disadvantages. One faulty device affects the entire network. Difficult to add more devices. Click Next to continue. Which of the following topologies requires terminators? Select the correct answer and click Submit. Sorry, the correct answer is match each network topology with the appropriate. In mesh topology, every device is connected to each other. There are several paths available for the data to reach its destination. An example of mesh topology is WAN. There are two types of mesh topologies: full mesh, partial mesh. In full mesh topology, all devices are interconnected. This may lead to several redundant connections. In partial mesh topology, the devices that exchange data with selected devices are connected to only those devices. This cuts down redundancy and expense. Advantages. Alternate path for data transmission is available. Entire network does not get affected by one faulty device. Centralized management is not required as in star topology. Easy to detect faulty devices. Disadvantages. More cabling required as compared to bus, star, and ring topologies. Each link from one device to another requires an individual network interface card, that is NIC. Data carrying capacity is underutilized unless all devices transmit constantly. Difficult to reconfigure. Click Next to continue. A tree topology combines the characteristics of linear bus and star topology. Multiple star networks are connected to the linear bus backbone. Tree topology enables the user to expand and configure the existing network depending on the requirements. Tree topology is also called as hierarchical structure. A tree topology connects multiple star networks. In the star topology, all devices are connected to a central hub. Multiple hubs are connected directly to a tree bus. Signals from a device first reach the hub to which it is connected. The hub then directs the signal to the tree bus, which then travels along the entire network. Advantages. Point-to-point wiring for each device. Easy to detect a faulty device. Easy to expand a network. Disadvantages. More difficult to configure and expensive as compared to other topologies. Fault in the backbone affects the entire network. Click Next to continue. Hybrid topology is a combination of different network topologies. It is also known as special topology. The commonly used combination of topologies is star bus or star ring. In a star ring topology, the ring topology is used to connect a series of star networks. Advantages. Useful for implementing large networks. Handles larger volume of traffic. Easy to detect and remove faulty devices. Disadvantages. More cabling required. More expensive. Complex structure. Installation and reconfiguration is difficult. Click Next to continue. Which topology is used? In this lesson, you learned that network is an interconnection of many communicating entities. Topology describes how computers are connected to each other. Physical topologies are how the wires are interconnected. Logical topology is how the network behaves and interoperates. Single node, star, bus, ring, mesh, tree, and hybrid are types of topologies. In single node topology, a dumb terminal is connected to the server. Bus topology connects each device to a single cable. In bus topology, cable terminators are used to remove unsent data. Click Next to continue. In this lesson, you learned that in star topology, multiple devices are connected to a hub or switch. In ring topology, data travels around a loop and passes through each device. In mesh topology, every device is connected to each other. In mesh topology, there are several paths available for data to reach its destination. Tree topology connects one star network to other star networks using bus topology. Hybrid topology is a combination of different topologies. Click Next to take a quiz. Welcome to the Networking Introduction Lab. Here, you will learn more about the fundamentals of networking. Click on a topic on the screen to continue. Networking involves a systematic connection of computers, workstations, and peripheral devices. It is done to share information and resources between a number of users. The hardware used in networking involves the peripheral devices, interface cards, and the equipment used to establish the connection. Click Next to continue. In this lesson, you will be able to explain the various transmission modes, list the various types of copper wired cables, discuss fiber optic cables, list the various types of wireless transmission media. Click Next to continue. Transmission modes indicate the direction of the communication. There are three types of transmission modes: simplex, half-duplex, full duplex. Simplex. The data is transmitted in only one direction. Only one device on the link can transmit. The other can only receive. Half-duplex. Both the devices can transmit and receive, but not simultaneously. When one device is transmitting, the other device can only receive. An example is a walkie-talkie. Full duplex. Both devices can transmit and receive simultaneously. Two separate channels are available to send and receive data. An example is a telephone system. Click Next to continue. Copper cables are the most widely used medium for data transmission as they are inexpensive. The types of copper cables available are twisted pair cables, coaxial cables. Click Next to continue. A pair of cables are interlaced with each other to form a twisted pair. A group of such twisted pair wires is placed inside a protective sheathing to form a cable. There are two types of twisted pair cables: unshielded twisted pair, that is UTP, shielded twisted pair, that is STP. Click Next to continue. UTP consists of a pair of unshielded wires wound around each other. The wires are wrapped in plastic insulators. UTP is widely used for LANs. UTP cables are divided into several categories. Click the images to learn more. Click Next to continue. A few more categories of UTP cables are shown. Click the images to learn more. Click Next to continue. STP consists of a pair of wires wound around each other. Each pair is wrapped in protective foil to prevent crosstalk. These wires are placed in a copper braid for protection from external interference. There are two types of STP cables. Click the images to learn more. Click Next to continue. An insulator made of PVC or Teflon surrounds a solid copper core. It is surrounded by shielding and an outer cover known as a sheath. The insulator acts as a barrier between the shielding and the inner core and prevents them from coming into contact with each other. The braiding gives protection from external interference. Click Next to continue. A coaxial cable has several different parts. Each part serves a specific purpose. Click the various boxes to learn more. When done, click Next to continue. Coaxial cables are mainly divided into 4 categories. The selection of the appropriate cable depends on the purpose and the application. The naming convention used is RG, that is, radio guide, followed by a number. Click the images to learn more. Click Next to continue. An optical fiber is a glass or plastic fiber that transfers data using light. It consists of a central glass core surrounded by a glass cladding. The cladding may be surrounded by PVC or metal fibers to provide strength and support to it. An outer cover, known as sheath, finally surrounds it. Click Next to continue. The electrical signal is converted into an equivalent light signal. The light signal is transmitted through the cable using the principle of total internal reflection. At the receiver, the light signal is again converted back into an electrical signal. The conversion is carried out using transceivers. A fiber optic cable carries data in a single direction. In order to send and receive signals to complete the round, you need to have 2 strands of cables. The 2 types of cables usually used are as follows. Single mode, multi-mode. Click Next to continue. It consists of a single strand with a thin diameter. This cable can transmit only a single light signal. It has less attenuation, provides high speed, and can carry data over a large distance. However, the disadvantage is that it can transmit only a single light signal at a time. Click Next to continue. It consists of a fiber with large diameter. Two or more different signals can be transmitted simultaneously through this cable. However, this cable causes a lot of signal attenuation, provides less transmission speed, and is suited for transmission over a short distance. Click Next to continue. A connector is a mechanical device that connects the fiber optic cable or the light source. The connectors used depend on the type of light source as well as the type of light sensor being used. Click the images to learn more. Click Next to continue. Splicing involves joining or connecting of two fiber optic cables. Splicing reduces the amount of light waves lost in transmission. Splicing is also used to restore a damaged or broken fiber optic cable. There are two types of splicing, namely fusion splicing and mechanical splicing. Click Next to continue. An apparatus is used to align the two fiber ends. The ends of the fiber are then fused or welded together by applying heat. The electrodes provide the heat. This technology reduces the loss in transmission. Carbon dioxide, lasers, electric arcs, or gas flames are used to generate heat. Click Next to continue. This is done using an alignment device such as a V-groove splicer. These devices hold the fibers in proper alignment. This allows light to travel from one fiber to another. The fiber ends are joined together either by clamping them within a structure or applying an adhesive that holds them together. Click Next to continue. Which of the following cables offers the best transmission speed? Which of the following are not advantageous? Wireless medium is an unguided form of transmission medium. Signals are transmitted through air and space using radio and satellite networks. In a wireless transmission, transmitters and receivers are used to send and receive data. Wireless transmission involves the use of technologies such as microwave, infrared, radio waves, lasers, and Bluetooth. Infrared and Bluetooth are used mainly in LAN environments, whereas microwave and radio waves are used to connect vast geographical locations. Click Next to continue. Wireless networking involves the use of radio waves to send and receive signals and can be used for short as well as long distances. Radio waves can be used for communication in all directions and the line of sight between the sender and receiver is not needed. The frequencies of radio waves range between 10 kHz to 1 GHz and are denoted as VLF, that is very low frequency, to EHF, that is extremely high frequency. There are two types of radio frequency technologies used: single frequency radio technology, spread spectrum technology. Click Next to continue. High frequency radio waves are used for point-to-point and unidirectional communication of audio, data, and video signals. This technique is widely used for long-distance telephone communication, cellular telephone, and television distribution. Microwave frequencies require direct line of sight to operate. Obstructions in the path usually distort or block the signal. The transmission distance covered depends on the atmospheric conditions. Microwaves do not pass well through buildings. Microwave transmission is divided into two categories based on the way in which the signals are transmitted between the transmission towers. The two categories are terrestrial, satellite. Click Next to continue. Infrared wireless transmission uses infrared light to send and receive signals. Devices use high-frequency beams of infrared light to communicate with each other. For communication to occur, line of sight must be maintained between the devices. Hence, this technology is mainly used in LANs. Light-emitting diodes, that is LEDs, or injection laser diodes, that is ILDs, are used as source of light to transmit information, and photodiodes are used as receivers. Infrared light waves cannot penetrate through obstacles and weaken as they travel away from the transmitter. The various remote controls used in televisions, VCRs, and stereos use infrared. Click Next to continue. What is the... In this lesson, you learned that networking hardware involves computers and peripheral devices. Different types of medium are available for data transmission. A few examples are copper, fiber optic, and wireless mediums. Copper medium includes coaxial cables and twisted pair cables. Twisted pair consists of a pair of cables twisted around each other. Two types of twisted pair cables are UTP and STP. There are 7 categories of UTP cables. STP cable types include Cat5e and 150 ohm shielded cable. Click Next to continue. In this lesson, you learned that coaxial cables offer protection against crosstalk and interference. RG8 cable is about 1 cm in diameter and is used as a backbone cable. Fiber cables consist of a glass core surrounded by a glass cladding. There are 2 types of fiber optic cables, single mode and multi-mode. Connectors used for fiber cables are ST, SC, SMA, fiber jack, and MIC. In wireless medium, signals are transmitted through air and space. Microwaves are used for point-to-point communication of data signals. Infrared networks use infrared light to send and receive signals. Click Next to take a...
Welcome to the Networking Basics Lab. Here you will learn about network, Ethernet, other network architectures, communication using a network protocols, and IP addressing. Click on a topic on the screen to continue. Ethernet is a local area network structural design developed by DEC, Intel, and Xerox Corporation, and is a standard communications protocol embedded in software and hardware devices for local area network. Ethernet uses a bus or star topology to connect different nodes in a network. Click Next to continue. In this lesson, you will be able to describe Ethernet standard, explain Ethernet, understand the concept of CSMA-CD and CSMA-CA protocols, explain different types of Ethernet, understand about repeaters, bridges, and hubs used to extend computer networks. Click Next to continue. Institute of Electrical and Electronics Engineers, that is IEEE, is an association that promotes engineering and electronic improvement. IEEE 802 committee defines frames, speed, distances, and types of cabling to use for networking. Click Next to continue. Protocols are a set of rules that the given nodes should follow to communicate with other nodes on a network. Protocol defines the procedure that is to be followed during data transmission. Protocols can be connection-oriented or connectionless. Click Next to continue. The main IEEE standards used with popular LAN architectures are 802.3, 802.4, 802.5. Click the various boxes to learn more. When done, click Next to continue. Ethernet is defined by IEEE as the 802.3 standard. It supports data transfer rates of 10 Mbps, 100 Mbps, and 1 Gbps. The three data rates currently defined for the operation over optical fiber and twisted pair cables are 10 Mbps 10 base T Ethernet, 100 Mbps Fast Ethernet, 1000 Mbps Gigabit Ethernet. Click Next to continue. Computers connected to an Ethernet transmit information to other computers or devices using frames. Ethernet networking creates a communication system that permits sharing of data and resources such as printers, scanners, and fax machines. The Ethernet system consists of three basic elements. Medium transmits Ethernet signals between computers. Set of medium access control rules permits number of computers to mediate access to the shared Ethernet channel. Ethernet frame includes a standardized set of bits used to transport information. Click Next to continue. The Ethernet medium is used to transmit information over the network. In the figure, computer D transmits a frame to printer C. The frame is transmitted over the Ethernet medium. It reaches every attached device on the network. When these devices receive the frame, they check the destination address in the frame. Only printer C accepts the frames and the remaining devices reject it. Click Next to continue. When a computer wants to transmit, it listens to a cable. If the cable is idle, it transmits data immediately. If two or more devices transmit data on an idle cable simultaneously, collision may occur. After collision, all colliding devices terminate their transmission, wait for a random amount of time, and repeat the whole process again. It is therefore necessary that in a network environment, multiple devices should not share the network medium at the same time. Click Next to continue. CSMA-CD is a type of contention protocol. Collisions may increase if several devices transmit data over an Ethernet medium. This may degrade the performance of existing bandwidth on an Ethernet medium. CSMA-CD avoids contention by checking the availability of a free medium. In CSMA-CD, a device senses the transmission medium to identify whether the medium is free by sensing a carrier on the medium. Carrier is a specific level of voltage used to transmit a frame. If a carrier is detected, the transmission is delayed until the carrier terminates and the transmission medium becomes free. If the medium is free, the device broadcasts the frame. At times, more than one device can also concurrently decide that the transmission medium is available and start to transmit frames. Collision occurs when two or more devices simultaneously broadcast frames. Frames that are transmitted together are corrupted due to collision. The device stops transmission of the frame and sends a collision enforcement signal to other devices on the network. When other devices receive the jam signal, they reject the frames that become corrupt due to collision. After sending the jam signal, the nodes involved in collision wait for an indefinite period of time and then retransmit the frames. Click Next to continue. The main purpose of CSMA-CA is to avoid collisions at the moment they are most likely to take place. Before starting a transmission, all devices are forced to wait for a random number of time slots and then sense the medium again. If the medium is sensed to be busy, the device halts its timer until it becomes free again. Click Next to continue. There are different types of cabling methods used for Ethernet. The type of cable for a network is dependent on the network's topology, protocol, and size. Click the images to learn more. When done, click Next to continue. Which of the following defines a standard for token bus architecture? A computer network can be extended using repeaters and bridges. Repeater removes the unwanted noise in an incoming signal and regenerates the signal. In computer networks, bridge is an inter-networking device. It connects a local area network to another local area network that uses the same protocol. Click Next to continue. A repeater is an inter-networking device. Signal tends to lose strength as it travels through the cable. A repeater corrects signal attenuation, rebuilds the signal, and transmits it to the network. Bridge is used to. A repeater is an inter-networking device. Signal tends to lose strength as it travels through the cable. A repeater corrects signal attenuation, rebuilds the signal, and transmits it to the network. Some of the advantages and disadvantages of repeaters are: they are cost-effective, as repeater simply repeats bits of data. It does not require any addressing information. Repeaters cannot connect segments of different type of network. Networks have a limit on the number of repeaters. Click Next to continue. Bridge is used to connect two LAN segments at the data link layer. Bridges can determine the physical addresses of the source and the destination stations involved in a data transfer. Some of the advantages and disadvantages of bridges are: bridges connect similar network types with different cabling. Bridges increase the number of attached workstations and network segments. Bridges are costlier than repeaters. Bridges may affect performance as they buffer data frames. Click Next to continue. Hub is basically a repeater with multiple ports. The functions of a hub and a repeater are similar. It is the simplest networking device which operates at the physical layer. Click Next to continue. In this lesson, you learned that Ethernet is a widely used method of networking computers in a LAN environment. Protocols are a set of rules that nodes on a network use to communicate. CSMA-CD is a network control protocol which uses a carrier sensing system. CSMA-CA is a set of rules used to avoid collisions. 10-2, 10-5, 10-T, and 10-F are types of Ethernet cabling. Repeaters, bridges, and hubs are used to extend computer networks. Click Next to take a quiz. Welcome to the Networking Basics Lab. Network involves connection of computers, workstations, and peripheral devices such as routers, switches, bridges, and hubs. These devices are interconnected with the help of a medium. There are several types of networks such as local area networks, wide area networks, and so on. Ethernet is the most widely used local area network technology and is formally defined by the IEEE 802.3 standard. The most commonly used Ethernet system is the 10-T, which provides a transmission speed of up to 10 Mbps. Knowledge of 10-T will help you understand current Ethernet technologies. Click Next to continue. In this lesson, you will be able to explain 10-T networks, explain the 543 rule, identify different types of high-speed Ethernet standards. Click Next to continue. The 10-T is the most popular implementation of Ethernet. It uses a physical star topology in which each node connects to a central hub. The hub receives the signals and regenerates them. The stations are connected to the hub using twisted pair cables. Ease of use of unshielded twisted pairs, that is UTP, cabling, and its low cost are some of the popular features of 10-T Ethernet. Advantages: fault tolerant. In 10-T, if a cable running to a specific node breaks or the computer itself fails, it affects only that computer, not the entire network. Easy troubleshooting. It is easy to troubleshoot a 10-T network. Easy moves and changes. Devices can be added and removed without affecting the network. Disadvantages: distance. In 10-T, the maximum distance from the hub to the node cannot exceed 100 meters. Sensitive to noise. As 10BASE-T uses UTP cable, it is sensitive to electrical noise. Number of computers connected. A 10BASE-T cannot connect more than 1024 computers. Click Next to continue. The 10 refers to the transmission speed of 10 Mbps. Base stands for baseband signaling and T stands for twisted pair cable. Hence, 10BASE-T is also known as twisted pair Ethernet. Click Next to continue. 10BASE-T wiring is specified using a set of characteristics like attenuation, impedance, propagation delay, and types of noise. Most UTP cables come with stranded Kevlar fiber, which gives the added strength to the cable. Click Next to continue. In 10BASE-FL, FL stands for the fiber optic link. It uses fiber optic cable for transmitting data. Fiber optic cable transmits data using light rather than electrical signals. Fiber optic cables are immune to electrical interference. The physical topology of 10BASE-FL is similar to 10BASE-T Ethernet. To build a 10BASE-FL segment and make connections to it, following components are used. Network medium. A multi-mode fiber optic cable is used. Straight tip, that is ST connectors are used. Link integrity test. 10BASE-FL medium attachment unit, that is MAU, monitors the link integrity status. Click Next to continue. The 543 rule was developed by IEEE 802.3 to limit the size of an Ethernet collision domain. The network has two categories of physical segments. User segments connect systems in the network. These segments are also called populated segments. Link segments connect repeaters in the network. These segments are also called unpopulated segments. The 543 rule states that any two nodes in the network should not be separated by more than 5 segments, 4 repeaters, and 3 populated segments. Hence, between any two nodes in a network, there can be a maximum of 5 segments, which are connected by 4 repeaters, and only 3 segments must be populated. Click Next to continue. Ethernet is based on the idea of computers communicating over a shared coaxial cable, acting as a broadcast transmission medium. High-speed Ethernet was developed in order to increase the connectivity speed between the computers in a particular network. The classification of Ethernet standards depends on the transmission speed. The various Ethernet standards are 100 base Ethernet, Gigabit Ethernet, 10 Gigabit Ethernet, Switched Ethernet, Full Duplex Ethernet. Click Next to continue. A 100 base Ethernet defines a networking standard that supports data transfer rate up to 100 Mbps. 100 base Ethernet is also known as a fast Ethernet. This type of Ethernet uses the CSMA CD access method for data transmission, which allows many devices to communicate without collision. It is further subdivided into two categories. Copper-cabled Ethernet. The electrical signals are transmitted over copper wires. Example, twisted pair cables. The different types of copper-cable Ethernet are 100 base TX, 100 base T4, and 100 base T2, and it depends upon the type of UTP used. Fiber-cabled Ethernet. Fiber optic cables are used for transmission of signals in which the electrical signals are converted to optical signals. The different cabling standards are 100 base FX, 100 base SX, and 100 base BX. Advantages: 10 times faster than regular 10 base T network. Supports stronger error detection and correction. Easy to install and maintain. Disadvantages: 100 base T4 cannot support full duplex mode of data transfer. Full duplex operation of 100 base TX Ethernet requires full duplex switches. Click Next to continue. Gigabit Ethernet provides speed of up to 1000 Mbps. It transmits data using unshielded twisted pair, that is UTP, category 5E or 6 cabling. Gigabit Ethernet is divided into 5 standards. 1000 base T is the most popular standard. Click the various boxes to learn more. Click Next to continue. 10 Gigabit Ethernet is the most recent and fastest Ethernet standard. It is 10 times faster than Gigabit Ethernet. It uses full duplex mode of transmission and runs only on fiber optic cables. 10 Gigabit Ethernet is further divided into 7 standards. Click the various boxes to learn more. Click Next to continue. Click the various boxes to learn more. Click Next to continue. Switched Ethernet uses a switch instead of a repeater or an Ethernet hub to connect individual hosts or segments. A switch operates at medium access control sublayer of the network access layer of the TCP/IP protocol suite. Switched Ethernet uses 3 different types of switches. Click Next to continue. An Ethernet switch defines its own collision domain that includes devices connected to one of its switch ports. The 3 different types of switching are cut-through, store and forward, fragment-free. Click the various boxes to learn more. Click Next to continue. A switched Ethernet connection which runs over UTP makes use of separate pairs of wires for sending and receiving data. Each pair of wires acts as a separate channel and allows the devices at each end to communicate with one another in full duplex mode. Click Next to continue. If the Ethernet NICs on each end of a switched connection are configured to support full duplex mode, the user can obtain twice the bandwidth. Click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Click the Configure button. Click the Advanced tab. Select the Link Speed and Duplex option. From the Value drop-down list, select the required configuration. For example, select the 100 Mbps full duplex option. Click OK. What is the matter? In this lesson, you learned that 10BASE-T is also known as Twisted Pair Ethernet and uses UTP cables. 10BASE-T uses star topology and hub is used as networking device. 10BASE-FL uses fiber optic link instead of twisted pair cable. 543 rule is used to limit the size of an Ethernet collision domain. High-speed Ethernet increases the connectivity speed between computers. Click Next to continue. Welcome to the Networking Basics Lab. Network architecture defines various network elements along with the structure of the network. It includes the design principles, physical configuration, operational procedures, and data formats. These are used as the basis for the design, construction, and operation of a network. Click Next to continue. In this lesson, you will be able to explain token bus logical topology, explain FTDI, describe signaling and connection standards, understand ATM, explain AppleTalk, explain ArcNet, explain MAN systems, SMDS and DQDB, describe Ethernet alternatives. Click Next to continue. Token Ring is a network architecture developed by IBM and is also known as IEEE 802.5. In this, all devices are connected in the form of a ring. The last computer is connected to the first computer. A special 3 bytes frame called token is used to decide which computer will initiate the data transfer. In the figure, Machine A wants to send data to Machine D. Machine A captures the free circulating token and uses the network to transmit the data. Now, the data and the other related information such as the destination address is attached to the token to form a data frame. The frame is now sent in a circular path. Each adjacent machine reads the destination address in the frame. If the destination address matches with the address of a receiving system, it accepts the frame and sends an acknowledgement. Else, the frame is transferred to the next adjacent machine. Click Next to continue. Token bus is defined by IEEE 802.4 standard. It uses a bus topology and token passing mechanism. The token is passed over a virtual ring within the bus network. Only the system which has token can communicate with other devices on the network. It is also possible to apply priorities to the data to be transmitted. In the figure, systems A, B, C, D, E, F, G, and H form a bus network. Systems A, B, D, G, and edge form a token bus network, that is, a virtual ring. All systems in the ring know the address of their immediate neighbors in the ring. Now, System A wants to transmit data. When System A receives the token, it will pass data to a destination system over the network. When System A finishes transmitting data, it will pass the token to System D, which is the next system in the virtual ring. Click Next to continue. Which of the following does not use token passing mechanism? Fiber LANs use different types of fiber optic cables for interconnecting systems. There are different types of fast Ethernet standards which use fiber optic cables. Click the various boxes to learn more. When done, click Next to continue. FDDI, that is Fiber Distributed Data Interface, provides high performance by connecting multiple stations at the data transfer rate of 100 Mbps. It uses a dual token passing ring topology. In this, there are two rings, and each ring runs at 100 Mbps, making an aggregate speed of 200 Mbps. FDDI is widely used in metropolitan area networks, that is, MAN. Click Next to continue. The FDDI network consists of a primary ring and a secondary ring. The computers in the network model are called as FDDI workstations. Each FDDI workstation is simultaneously connected to both the rings. Data transmitted on the primary and the secondary ring flow in the opposite direction. The secondary ring acts as an alternative path for data if the primary ring fails to transmit the data. FDDI uses the token passing access method. A device needs to acquire the token before transmitting data. Click Next to continue. There are two types of FDDI workstations: single attached station, that is SAS, dual attached station, that is DAS. Single attached station. It is connected to the FDDI network through a single connector called the S port. S port has primary input P-in and primary output P-out, through which data enters from an upstream station and exits from a downstream station respectively. Dual attached station. It has two ports A and B. DAS can be connected to the primary and the secondary rings of FDDI using these two ports. A port has one primary ring input, P-in, and one secondary ring output, S-out. B port has one primary ring output, P-out, and one secondary ring input, S-in. Click Next to continue. FDDI concentrators are used to connect FDDI stations to the network. FDDI concentrator is a multiplexing device similar to an Ethernet hub. It is the building block of FDDI network. The different types of concentrators are as follows: single attached concentrator, SAC, dual attached concentrator, DAC. Single attached concentrator. It is connected to the FDDI network through a single connector. The single connector is similar to S port. Single attached stations are connected to multiple M ports. Dual attached concentrator. It is connected to the FDDI network through the A port and B port, identical to the ports on a dual attached station. Single attached stations are connected to multiple M ports. Click Next to continue. Every classic FDDI device requires two connectors to support two rings. Using fiber optic cabling, FDDI segments could reach up to 2 km between systems, with a maximum ring size of 100 km. Click Next to continue. CDDI stands for Copper Distributed Data Interface, and it uses twisted pair copper cable instead of fiber optic cable. It provides redundancy by making use of dual-ring architecture like FDDI. It supports connection of desktop and concentrator which are about 100 meters apart. Click Next to continue. The signaling and connection standards are used to ensure that the equipment used for creating networks will work together. The standards for signaling over fiber and for making fiber optic cable connections are Fiber Distributed Data Interface, that is FDDI, Fiber Optic Inter-Repeater Link, that is FOIRL 10 base F. Click Next to continue. FDDI networking scheme is highly reliable as it provides redundancy and sophisticated data handling protocols. Equipment used in FDDI are highly reliable and fast, and they provide data rate of 100 Mbps. FDDI2 is an extension to FDDI, which enables a single fiber cable to carry voice and video signals along with data. FDDI2 provides speed up to 200 Mbps. Click Next to continue. FOIRL and 10 base F standards are used to extend the distance or operational capability of signal over a fiber optic link. FOIRL is an old specification used to connect repeaters which are at least 2 kilometers apart. FOIRL devices typically use ST connector, a fiber optic cable connector that uses a plug and a socket. Many transceivers followed the FOIRL standard. The 10 base F standard is a part of the IEEE 802.3, that is Ethernet specifications. It has two variations. 10 base FP describes the backbone connection between cable hubs. 10 base FL describes the connection between LAN nodes and a cable hub. Click Next to continue. ATM is a network protocol which converts data traffic into a stream of fixed-size cell before transmission. The ATM technology can be employed in both LAN and WAN environments. It can provide a maximum data speed of 622 Mbps. It is a high-speed transfer technology for voice, video, and data over public networks. Click Next to continue. The performance of ATM switching system is mainly characterized by 5 parameters. They are throughput, connection blocking probability, cell loss probability, switching delay, and cell delay variation. Click the various boxes to learn more. When done, click Next to continue. AppleTalk Protocol Suite was developed by Apple Computers for use on Macintosh computers to allow multiple users to share resources such as documents, files, and printers. The resources to be shared among the users are stored on a device called server. The user workstations which form the network are called clients or nodes. Click Next to continue. AppleTalk networks are arranged hierarchically. An AppleTalk internetwork is formed with the help of the following basic components: sockets, nodes, networks, zones. Click the various boxes to learn more. When done, click Next to continue. LocalTalk is a popular piece of networking software found on every Apple brand computer. It is implemented at the data link layer. LocalTalk has now become obsolete. The aim for designing LocalTalk was to come up with a cost-effective network solution for connecting local work groups. Click Next to continue. Attached Resource Computer Network, that is ArcNet, was the first LAN system introduced by DataPoint Corporation. The network can support 255 nodes and can transmit data at a rate of 2.5 Mbps. ArcNet supports segment lengths up to 600 meters, and it uses a token passing bus structure. The logical structure of ArcNet is always a star. Though it has disappeared from the PC networking world, still it is popular in robotics and industrial controls market. The token is a unique signaling sequence that is passed in a particular order among all the active nodes of the network. A node can initiate data transmission after it receives the token. The token is passed to the logical neighbor of the present node after the data transmission is completed. Click Next to continue. An ArcNet is developed with the help of hubs, repeaters, and NICs. The different types of devices that may be used in designing an ArcNet network are Active Hub, Passive Hub, ArcNet Card, BNC Terminator. Click the images to learn more. Click Next to continue. MAN connects different LANs. It can cover large distances to function across a city. It requires systems which are less susceptible to error. The systems used in MAN are Switched Multi-Megabit Data Service, that is SMDS, Distributed Queue Dual Bus, that is DQDB. Click Next to continue. Switched Multi-Megabit Data Service is a high-speed packet-switched MAN technology used for communication over public data networks, that is PDN. SMDS was the first broadband service provided to the public. It is a connectionless service and provides less expensive means of linking networks than dedicated lease lines. The SMDS network acts as a high-speed LAN backbone that allows the packets to flow from one LAN to another. A short access line leased from a telephone company is used between LANs. Every LAN is connected to a telephone company switch. The switch helps to transfer packets to reach the destination. Click Next to continue. The SMDS network consists of devices which provide a high-speed data transmission service. The devices used in SMDS are Customer Premises Equipment, that is CPE, Carrier Equipment, Subscriber Network Interface, that is SNI. Click the various boxes to learn more. When done, click Next to continue. Ethernet cabling cannot be implemented everywhere due to its physical limitations. To overcome this problem, no-new-wire networking technologies can be used, which allows connecting two or more computers into a LAN without running a wire. The three no-new-wire networking technologies are wireless LANs, phone line networks, power line networks. Click Next to continue. Phone line networks work on the existing phone wiring. The LAN and telephone signals make use of the same copper wire, but both the signals are electrically distinct and completely invisible to each other. Phone line LANs do not interfere with normal operation of the phone. Phone line networks provide satisfactory performance. that is DTR of 1 Mbps, at a much lower cost than wireless systems. Click Next to continue. In this lesson, you learned that token ring and token bus are the two logical topologies. A token passing mechanism is used in both token ring and token bus. SAS and DAS are the different types of FDDI stations. ATM network protocol converts data into a stream of fixed size cell before transmission. Apple Computers has designed a protocol suite known as AppleTalk. AppleTalk network components are sockets, nodes, network, and zones. Click Next to continue. Data and resources between the interconnected nodes. For connecting the nodes, a hardware device called the Network Interface Card or NIC is used. There are certain principles of data communication to be followed during communication. Click Next to continue. In this lesson, you will be able to state and explain the different components of a network, explain and install Network Interface Card, describe the basic principles of data communication, explain the use of MAC address, identify and troubleshoot problems of NIC. Click Next to continue. Data transmission is the process of transmitting and receiving data between different nodes using an electronic medium. The basic components involved in data communication are sender, receiver, medium, message, and protocol. The sender initiates the communication. To send the data, a connection needs to be established with the appropriate node. The data is transmitted in the form of bits. The receiver responds to the call made by the sender. It is a node with which the connection is established. The receiver receives the data sent by the sender. Medium is the channel or a pathway through which the information is transmitted by the sender to the receiver. It can be defined by a physical wire which connects the devices, or wireless such as radio waves, laser, or other radiated energy source. Message is the information that is transmitted by the sender to the receiver through the medium in the form of bits. The sender selects a secure medium and sends data to the receiver in an encoded form. The receiver, on receiving the data, decodes it to view the actual data sent by the sender. Protocol is a set of rules and regulations that are followed during the process of communication. Both the sender and the receiver should follow these rules to communicate with each other. Some of the examples of protocols are IP, TCP, and HTTP. Click Next to continue. Data can be transmitted using either baseband or broadband signaling technique. The technique used for data transmission depends on the number of frequencies used to transmit the data. Click Next to continue. Baseband signaling is a technique which uses a single frequency to transmit data over a cable or a wireless path. Baseband signals transmit information in a digital form. Broadband signaling is a technique in which data is transmitted using more than one frequency along a single cable or wireless path. Mostly broadband signaling makes use of analog signals and uses frequency division multiplexing or FDM to create separate channels. An example of broadband signaling is cable TV. In broadband signaling, the network adapters act as radio transmitting and radio receiving stations. They insert a wide range of radio frequency into the cables. Complex radio repeaters are used in between these radio transmitting and receiving stations. Click Next to continue. Which of the following? In a network, each node is identified by a unique address to send and receive data. This address is known as physical or MAC, Media Access Control Address. It is provided by a device known as Network Interface Card or NIC, which is used to connect a node on a network. Network Interface Card is a hardware device and is fitted into an expansion slot inside a computer. It serves as a link for sending and receiving data on a network. It can support a data transfer rate of 10, 100, or 1000 megabits per second. Click Next to continue. Ethernet card and token ring card are the two types of network interface cards. Ethernet card is used in nodes which are connected using Ethernet technology, and token ring card is used in nodes which are connected using token ring network. Click Next to continue. Ethernet cards are of two types, wired and wireless. Wired cards cannot communicate with wireless cards, and vice versa. Ethernet cards are divided into several categories. Click the images to learn more. Click Next. A token ring card is an adapter card that a node uses to connect to a token ring network. It also has a MAC address assigned by IEEE. A maximum of 2 token ring cards can be installed on a node. Out of these 2 cards, one is set as a primary card and the other as an alternate card. A token ring card consists of a 9-pin DIN type connector, which is used to connect the card to a network cable. The connectors are of 2 types, a female DB9 and an RJ45 connector. A token ring card may contain only DB9, RJ45 or both the connectors. Click Next to continue. The network interface card can either be connected on a peripheral component interconnect, that is PCI slot, or in a PCI X slot present on the motherboard. Some of the latest NIC cards can also be connected to a USB port, or the user can also have a PC card connection, that is, onboard LAN connection. Click Next to continue. Various lights are present on an NIC. Some NICs may have 1 or 2 light emitting diodes, that is LEDs, while some others may have 4 LEDs. These LEDs indicate the various status and help the user to identify the NIC related problems. The lights that may be present on NIC are as follows. Link LED indicates whether any network connection is present between the NIC and the hub. ACT LED, also known as activity light, glows only when any network activity takes place. Speed LED indicates the speed of the network. Collision LED glows whenever a collision takes place in the network. Click Next to continue. Hub contains 2 types of LEDs, the power LED and the port LED. Power LED is used to determine the power status, whereas the port LED is used to indicate the port status. The green light on the power LED indicates that the hub is powered on. The ports with green lights glowing at their respective ports are active, whereas the other ports are inactive. Click Next to continue. MAC address is a unique hardware address that is embedded in a NIC. It operates at the data link layer of the OSI model and is a 12-digit hexadecimal number, that is a 48-bit address. The MAC address is made up of numbers from 0 to 9 or a letter from A to F. MAC addresses can be written in the following formats, as shown on the screen. The first half of the address represents the ID number of the manufacturer, and the second half represents a serial number for that NIC provided by the manufacturer. Click Next to continue. MAC address is the media access control address, whereas the IP address is the Internet Protocol address. The address is used to identify the nodes depending on the layer where the data is present. The lower levels do not recognize the IP address. Table shows the difference between the MAC and IP address. Click Next to continue. NIC is needed to put a computer on a network. For installing a NIC, you need to first locate the appropriate empty expansion slot on the motherboard. Then remove the expansion card slot cover and fit the NIC in the expansion slot. Finally, screw up the NIC with the screw you removed from the expansion card slot cover. Click Next to continue. To configure the NIC on Windows XP, select Start. Click Control Panel. Click Network Connections. Double-click Local Area. Click the Properties button. Select the show icon in Note. From the This connection uses the following. Click the Properties button. Select the Obtain DNS. Click OK. Click the Close button. A user can also use another method known as direct cable connection for connecting 2 computers. The latest versions of Windows provide a software which allows a user to have direct serial-to-serial, parallel-to-parallel, or infrared-to-infrared connection with another PC. To establish a parallel connection, the user requires a special 1:8 rated bidirectional parallel cable, whereas to establish a connection using serial ports, a cable known as null modem is used. After the connection is established, the two connected nodes can share their hard drives. Click Next to continue. There can be various reasons for a network to stop functioning. To troubleshoot a network problem, you have to check various aspects such as the physical connectivity, the LEDs of a particular NIC, the NIC, driver and physical connections, the network by the help of various tools. Click Next to continue. Various tools are used to diagnose network problems. The tools are also used to measure different network parameters such as voltage and resistance of cables. There are various tools such as a voltometer and probe generator. Click Next to continue. Voltometer is a cable testing tool which is used to measure parameters such as AC and DC voltages, current, resistance, capacitance, and cable continuity. Voltometer is used to troubleshoot controllers, transformers, solenoids, and field wiring. Voltometers are of two types. Click Next to continue. An analog voltometer uses a needle to provide a reading. The value is determined using the calibrated scale present on the voltmeter. Click Next to continue. A digital voltometer uses a digital display. The value obtained is directly displayed on the display screen provided. The advantage of digital multimeter is that as the value is displayed directly on the screen, the possibility of human error is low and it is more accurate. Click Next to continue. Tone generator is a network troubleshooting tool. It consists of a single or multi-tone signal, 2 test leads, and a 4-conductor modular cable. A tone generator, that is toner, acts like a radio transmitter. The alligator clips of the tone generator are attached to a pair of wires, or its plug is attached to a phone or a data jack. After the plug is attached to the jack, the toner sends a sound through the wire. The probe works like a radio receiver. It catches the tone when it is placed near a wire. It has the ability to catch a tone even if the wire is present in the middle of a bundle of wires or is inside a wall. Click Next to continue. Fiber optic cables are very delicate, and the connectors that connect to the NIC are the region that need not be handled carefully. So whenever a problem arises, the first part to check is the connectors. An optical tester is used to inspect the quality of the connections. Click Next to continue. Cannot access network when the My Network Places icon is double-clicked. Click Next to view the basic checklist you must follow while troubleshooting the computer. Follow these steps to troubleshoot a networked computer. Click Next to continue. User gets automatically disconnected from the network. Sometimes the user may get automatically disconnected from the network while accessing the resources. Follow these steps to troubleshoot a networked computer. Click Next to continue. In this lesson, you learned that main components of data communication: sender, receiver, medium, and message. Signaling techniques are of two types: baseband and broadband. Baseband signals transmit data at a single frequency. Broadband technique can transmit data using more than one frequency. Network interface card is a device used to get connected on a network. Some examples of NIC are Ethernet card and token ring card. Click Next to continue. In this lesson, you learned that Ethernet cards support transfer rate of 10 or 100 or 1000 Mbps. MAC address is a hardware address that is embedded onto the NIC. Two nodes connected directly with the cable is called direct cable connection. Voltometer is a cable testing tool used to troubleshoot network cabling. Voltometer is used to measure voltage, resistance, and to check cable continuity. Tone generator and probe is another network troubleshooting tool. Click Next to take a quiz. encapsulation, decapsulation, queuing. Click Next to continue. In UDP, data is passed in the form of packets. These UDP packets are called as user datagrams. User datagrams consist of 8 bytes header and data. The different fields of the header are source port number, a 16-bit field that specifies the port number of the application running on the sending device, that is host. This number varies from 0 to 65535. Destination port number, a 16-bit field that specifies the port number of the application running on the destination device. Length, a 16-bit field that provides the total length of the user datagram, including the header and data. Checksum, a 16-bit field that can be used to detect errors over the entire user datagram. Click Next to continue. When UDP receives data, it adds its own header to the data and then passes the datagram to the IP. IP adds its own header and then this IP datagram is forwarded to the data link layer where a header and a trailer are added to the data. The final frame is then passed to the physical layer. This process is called encapsulation. Click Next to continue. Decapsulation is the opposite of encapsulation and takes place at the destination. Click Next to continue. IPX-SPX is a communication protocol of the novel NetWare operating system used by the clients and server to transfer data within the networks. IPX, that is Inter-Network Packet Exchange, is a network layer protocol used for connectionless communication, whereas SPX, that is Sequence Packet Exchange, is a transport layer protocol used for connection-oriented communication. Click Next. IPX-SPX uses two types of IPX network numbers for routing purposes. Internal network number. It is a hexadecimal number with 1 to 8 digits, that is 1, 2, FFFF, FFFE. It is referred to as a virtual network number since it identifies a virtual network within a computer. External network number. It is a hexadecimal number with 1 to 8 digits. This number is linked to physical network adapters and networks. Computers that are part of the same network and use a given frame type must have the same external network number. If not, then these computers cannot communicate with each other. In the figure shown alongside, the number 1C32A9B3 is the internal network number. It identifies the NetWare server. The number 976-54321 is the external network number. It is combined with the MAC address of every computer on the network. This combination identifies every computer on the network. Click Next to continue. To configure IPX-XPX on Windows XP, first install NWLink IPX-SPX NetBIOS compatible transport protocol by following the steps above in this chapter. Then, in the Local Area Connection Properties dialog box, select NWLink IPX-SPX NetBIOS compatible transport protocol and click Properties. Enter the internal network number in the internal network number text box. Select the appropriate frame type from the frame type drop-down list box. Click OK. Click Close. Data link control, that is DLC protocols, are a set of transmission protocols used at the data link layer. DLC protocols are of two types, asynchronous and synchronous. Asynchronous protocols have no synchronization between the sender and the receiver during data transfer. In synchronous transmission, data packets contain the control information for synchronization. Two synchronous protocols used are High-Level Data Link Control, that is HDLC protocol, and Synchronous Data Link Control, that is SDLC protocol. These are bit-oriented protocols in which data frames are interpreted as series of bits. HDLC provides a data transmission mechanism at the data link layer. Data is encapsulated into a frame before sending it to the lower layers. HDLC is used for both half-duplex and full-duplex communication. It ensures that the data is received error-free, without loss, and in the correct order. SDLC protocol is a bit-oriented protocol invented by IBM and similar to HDLC. SDLC frame format is exactly same as that of HDLC. Click Next to continue. In this lesson, you learned that network protocols are a set of predefined rules. They are used by devices to communicate with each other. Different network protocols are NetBIOS, NetBEUI, TCP/IP, and IPX/SPX. NetBIOS protocol operates at the session layer of the OSI model. NetBIOS provides name service, session service, and datagram service. Name service allows an application to register its NetBIOS name. Session service is a connection-oriented service for data transfer. In datagram service, data is transferred in the form of datagrams. Click Next to continue. In this lesson, you learned that ARP protocol returns physical address when logical address is known. RARP protocol returns logical address when physical address is known. ICMP protocol is used to send error and control messages. Two types of ICMP messages are error reporting and query messages. IGMP protocol governs the management of multicast groups in a network. Three IGMP messages are query, membership report, and leave report. UDP protocol operates at the transport layer. UDP protocol provides connectionless and unreliable service. Click Next to continue. Welcome to the Networking Basics. A unique number called the Internet Protocol, that is IP address, identifies every machine that is on a network. The IP address is a unique 32-bit logical address expressed as 4 decimal numbers, each representing 8 bits separated by periods. For example, 192.168.0.100. IP addresses are of two types, static and dynamic. Static IP addresses never change. That is, a device assigned a static IP address will always use the same address. On the other hand, in dynamic IP addressing, the IP address for a device will change each time the device connects to the network. Click Next to continue. In this lesson, you will be able to explain difference between dynamic and static addresses, identify different classes of IP addresses, describe IP subnet, identify IP masks, explain CIDR using VLSM, explain special IP addresses. Click Next to continue. The scheme of IP addressing using address classes is called classful addressing. This addressing scheme does not allow any other network prefix address. IP address contains two addresses embedded within one IP address: network address and host address. The class of the address determines which part belongs to the network address and which part belongs to the host address. They are divided into various classes, namely Class A, Class B, Class C, Class D, and Class E. Class D is used for multicasting, while Class E is used for experimental purpose. Click Next to continue. Class B addresses consist of a 16-bit network ID and a 16-bit host ID. This address class consists of 16,384 network blocks. The first block starts from 128.0.0.0 to 128.0.255.255. In this address class, the first 2 bytes represent network ID, that is 128.0.x.x, where x is any number between 0 and 255. Class B provides 16 special and reserved network address blocks. Each network address block in this class contains 65,536 host addresses. An example of a Class B IP address is 168.212.226.204 where 168.212 identifies the network and 226.204 identifies the host on that network. Click Next to continue. Class C addresses consist of a 24-bit network ID and an 8-bit host ID. The first network block starts from 192.0.0.0 to 192.0.0.255. This address class supports 2,097,152 network blocks. In this address class, the first 3 bytes represent the network ID, that is 192.0.0.x, where x is any number between 0 and 255. Class C provides 256 network blocks, which are reserved for private addresses. Each block of Class C address provides 256 host addresses. An example of a Class C IP address is 200.168.212.226, where 200.168.212 identifies the network and 226 identifies the host on that network. Click Next to continue. To configure an IP address in Windows XP, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Select Internet Protocol, that is TCP/IP, and click the Properties button. Select the Use the following IP address option. Enter the appropriate IP address in the IP address text box. Enter the appropriate subnet mask address in the subnet mask text box. Enter the appropriate default gateway address in the default gateway text box. Click OK. Internet comprises of many computer networks. Communication on these computer networks can be achieved either by using unicast, multicast, or broadcast addresses. Click the various boxes to learn more. Click Next to continue. A subnet mask specifies the part of IP address that is to be used to identify a subnetwork. Each class has a default subnet mask. The logical AND operation between the subnet mask and the IP address gives a 32-bit network address. This address specifies the first address of the subnet block. Click Next to continue. As the size of the internet is growing, the need for IP address is also growing. In Class A addressing, it was difficult to have a huge number of hosts on the same network. Hence, many of the Class A IP addresses were wasted. To overcome this limitation of classful IP addressing, a new scheme called classless IP addressing was developed. In classless addressing, the network address is of variable size. Therefore, the network address can borrow bits from the host address to extend the number of network blocks as required. Click Next to continue. Classless interdomain routing, that is CIDR, is a classless addressing scheme of IP addresses which provides flexibility and efficient use of IP addresses as compared to the classful addressing scheme. CIDR address blocks are identified using syntax similar to IPv4. IPv4 contains 4-part dotted decimal address followed by a slash. A number ranging from 0 to 32 then follows the slash. This number indicates the number of bits required for the network ID. For example, if the address using CIDR notation is 128.211.168.0/21, then the first 21 bits are used for the network ID and the remaining 11 bits represent the host ID. Click Next to continue. CIDR makes use of variable length subnet mask, that is VLSM, to allocate IP addresses to subnets depending on the need of the organization. Variable length subnet mask allows the network administrator to create variable size subnets within a network. Consider the following scenario, where VLSM is used to create subnets within a network. An organization has 3 branches. It has been granted an IP address 190.100.0.0.0/16. Branch 1 requires 64 networks, while each network needs 254 addresses. Branch 2 requires 128 networks, while each network needs 126 addresses. Branch 3 requires 128 networks, while each network needs 62 host addresses. The procedure followed is: for branch 1, each network needs 254 host addresses. So the number of zeros, that is hosts, in the address required is 8, as 2 raised to 8 is equal to 256. Hence, the remaining 32 minus 8, that is 24 bits, is the prefix or network address. The range of host addresses is as shown. For branch 2, each network should have 126 host addresses. The number of zeros required for representing host addresses must be 7, as 2 raised to 7 is 128. Hence, the first 25 bits, that is 32 minus 7 equal to 25, gives the network address. The range of host addresses is as shown. For branch 3, each network should have 64 host addresses. That is, the number of zeros required for representing host addresses must be 6, as 2 raised to 6 is 64. Hence, the first 26 bits specify the subnetwork address, as 32 minus 6 is 26. The range of host addresses is as shown. Click Next to continue. Special IP addresses are IP addresses which are never used on the public internet. The types of addresses that belong to this category are private, loopback, link local. Click the various boxes to learn more. Click Next to continue. Network protocols like Internet Control Message Protocol include various error reporting and query tools for checking the working of Internet. In addition, utility tools like ping, path ping, and tracert are used for keeping track about the hosts on the network and the network structure. Click the various boxes to learn more. Click Next to continue. To ping a host, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type ping followed by an option and the host IP address or name. Click Next to continue. To perform tracert through Windows command prompt, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type tracert followed by an option and the remote host IP address. Click Next to continue. To perform path ping through Windows command prompt, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type path ping followed by an option and the remote host IP address. Click Next to continue. When a host moves from one network to another, it requires its IP addressing structure to be modified. This can be implemented by either changing the IP address or using two IP addresses. Two agents, the home agent and foreign agent, are used to make the address changes invisible to the rest of the internet, not using mobile IP. Home agent involves a routing device attached to the home network of the mobile host. Every site that wants to allow its user to roam has to create a home agent. Foreign agent is usually a router that is attached to a foreign network. Every site that wants to allow visitors has to create a foreign agent. Click Next to continue. A mobile host, to communicate with a remote host, has to undergo 3 phases. In the first phase, the mobile host must discover the home agent before it exits the home network, and it must discover the foreign agent before it enters the foreign network. This phase is called the agent discovery phase. The second phase involves the registration of the mobile host. The mobile host must register itself as it moves to a foreign network and discovers a foreign agent. This phase is called the mobile host registration phase. When the mobile host returns to its home network, the mobile host must cancel its registration. After the mobile host has registered itself, it can start communicating with the remote host. The communication takes place through 4 ways: from remote host to home agent, from home agent to foreign agent, from foreign agent to mobile host, from mobile host to remote host. Click Next to continue. Mobile IP sometimes may provide with inefficient communication, which can be either severe or moderate. There are 2 cases which cause inefficiency in mobile IP. These are double crossing or 2x, triangle routing. Click Next to continue. Double crossing occurs when a remote host tries to communicate with a mobile host who has moved to the same network as of the remote host. When the mobile host sends an IP packet to the remote host, the communication between them is local and efficient. However, when a remote host sends an IP packet to a local host which is currently in the same network as the remote host, it causes inefficiency as the packet has to cross the internet twice. Click Next to continue. Triangle routing occurs when a remote host wants to communicate with a mobile host that is not connected to the same network as that of the mobile host. There is an efficient communication when a mobile host sends an IP packet to a remote host, but it is not the same the other way around. When a remote host sends a packet to the mobile host, the packet has to travel from the remote host to home agent and then to mobile host. Hence, the IP packet has to travel through the 2 sides of a triangle instead of one side. Click Next to continue. In this lesson, you learned that an IP address is an unique address assigned to a device over a network. An IP address is divided into various classes: Class A, B, C, D, and E. In classless addressing, the network address is of variable size. Subnetting creates multiple logical networks within a single network. Subnet mask is a 32-bit IP address used to derive network address. VLSM is used to allocate IP addresses to the subnets as per the needs. Click Next to continue. In this lesson, you learned that routing devices on internet discard any packet with private IP address. Loopback address is used as a test mechanism to test network devices. IPv6 implements a 128-bit IP address. Mobile IP allows devices to move between networks. Click Next to take a quiz. Welcome to the Networking Basics Lab. Here you will learn about network,
Welcome to the Installing Networks lab. In this module, you will learn about various networking devices, tools used, and the procedures for installing a network. You will also learn about the standards, components, and applications of wireless networking. Click on a topic on the screen to continue. Networking devices connect multiple LANs together to extend a network. They act as intermediate agents for transmission of data in the network. These devices include repeaters, bridges, routers, hubs, etc. They manage networks by dividing a single network into multiple subnetworks. Click Next to continue. In this lesson, you will be able to explain a repeater, explain the working of a bridge, explain the working and features of routers, explain the operation of hubs, discuss the working of a switch, explain gateway, explain multi-protocol routers, and layer 3 switches, troubleshoot different networking devices. Click Next to continue. Repeater is a networking device which regenerates signal. It works at the physical layer of the OSI model and connects two segments of the same LAN. It removes unwanted noise from the signal. There are two types of repeaters, analog and digital repeaters. Click Next to continue. A repeater is not an intelligent device. It simply receives the signals from the cable and retransmits the signal back to the cable. The analog repeater amplifies the input signal, whereas the digital repeater reshapes the signal near to its original quality. Click Next to continue. Hub operates at the physical layer of the OSI model. It allows multiple devices to be connected from a single network segment and can connect different media types such as twisted pair and coaxial cable. The operation of hub varies depending on the type of hub. Click Next to continue. The different types of hubs are passive hub. It does not require power as it does not regenerate the received signal before forwarding. Active hub. It needs a power supply as it regenerates the received signal before forwarding. Intelligent hub. It provides additional features to the active hub. It is also known as a manageable hub. Click Next to continue. Hub passes received data to all the other ports without checking for the destination device except the port through which it receives the data. In the figure, device A wants to send data to device D. When device A sends data, the hub receives it through one port and transfers data to all the connected segments instead of passing it to only device D. This feature of hub leads to congestion and extends the collision domain. Click Next to continue. A single hub can be used in a small network. For expanding networks, multiple hubs with different configurations can be used. The configurations of hub are standalone hubs, stackable hubs, modular hubs. Click the various boxes to learn more. When done, click Next to continue. Bridge is a data link layer device. It connects two LAN segments. Bridges are classified into two types. Local bridges directly connects multiple segments of a LAN which are physically close to each other. Remote bridges connects multiple segments of a LAN which are placed in different locations. Click Next to continue. Bridge maintains a table that contains the MAC addresses of the connected nodes. This table is called as forwarding table and it is used to map the MAC addresses with the port numbers while forwarding the frames over the network. Bridge learns which computers are on the either side of the bridge with the help of this table. Device B wants to transfer a frame to device D as shown in the figure. Bridge receives the frame from device B and checks the destination MAC address, which is the MAC address of device D. As device D is connected to the same segment of B, the bridge restricts the frame from being transmitted to the other segment and sends it directly to device D. However, devices A and C also receive the frame as they are located on the same segment. Now, device B wants to transfer frame to device H, which is on the other segment. The bridge checks the destination MAC address and transfers the frame to the other segment where device H is present. Click Next to continue. Bridges are classified into 3 types depending on their working. Different types of bridges include transparent bridge, translational bridge, and source root bridge. Click the various boxes to learn more. When done, click Next to continue. At which a switch is a networking device which filters and forwards packets through the network. It is a layer 2 device and is more advanced than a hub. The basic function of a switch is to manage the signal flow. When the switch is open, it allows the signal to flow through it, and when it is closed, it stops the signal flow. Click Next to continue. Switch forwards data only to the port on which the destination system is connected. In the figure, device A wants to send data to device B. When device A sends the data, switch receives it. Switch then checks the MAC address of the destination system and then transfers data to device B only instead of broadcasting to all the devices. Click Next to continue. Switch uses one of the 3 methods of switching to send data over the network. Click the various boxes to learn more. When done, click Next to continue. Router is an intelligent network layer device used to connect 2 or more network segments that may be near or far and having different types of cabling. Router has several LAN ports and 1 WAN port. Routers can be divided into 2 types, a regular router and a gateway router. Click Next to continue. Routers maintain routing tables that provide information about the path from router to the destination. The 2 commands that allow you to view the routing table are shown in the figure. The routing table generally consists of a number of routes. Each route has information such as network destination, net mask, gateway, interface, and metric. This information is necessary to determine where the packet will be sent. Click Next to continue. Router checks the destination address of the received packet. Depending on the destination, router selects the best route for the packet from its routing table. In the figure, device A wants to send the packet to device G. The packet arrives at router 1, that is R1. R1 checks the source and the destination IP address of the packet in its routing table. Since the destination does not lie on the segment to which the router R1 is directly connected, the router checks the routing table and passes the packet to the next router, that is R2, specified in the table. When R2 receives the packet, it also checks the routing table and passes the packet directly to device G. Thus, the router selects the best route for the packet. Click Next to continue. Routers communicate with each other using routing protocols. Routing protocols use routing algorithms to decide the best output path for the received packet. For finding the best path, router considers number of hops, time delay, and communication cost of the packet transmission. The Internet is divided into groups of networks called as autonomous systems, that is, AS. This system consists of network groups and routers which are managed by a single organization. Routing can be classified on the basis of AS. Interior routing is used within AS, whereas exterior routing between two ASs. Click Next to continue. The various routing protocols are Routing Information Protocol, that is RIP, Interior Gateway Routing Protocol, that is IGRP, Enhanced Interior Gateway Routing Protocol, that is EIGRP, Open Shortest Path First, that is OSPF Protocol, Intermediate System to Intermediate System, that is ISIS Protocol, and Border Gateway Protocol. Click the various boxes to learn more. When done, click Next to continue. Gateway is a networking device which acts as an entrance or a gate for another network. Mostly, the gateway is the computer that routes the traffic from an internal network to the outside network. The basic function of the gateway is to translate data from one format to another. Click Next to continue. As gateway works at all levels of the OSI model, there are different types of gateways. Click the various boxes to learn more. When done, click Next to continue. To configure Gateway in Windows XP, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Select Internet Protocol, TCP/IP, and click the Properties button. Select the Use the following IP address option. Enter the default gateway address in the default gateway text box and click OK. Click the Close button. Which gate? Backbone is a central segment to which other segments are connected. It provides connectivity to all the users in a network. A user from one segment can communicate with the other through the backbone segment. In most cases, the segments which are connected to the backbone run at a lower speed than that of the backbone. In the figure, the 10 base T ports of the Ethernet switches are connected to the computers and the 100 base T switch ports of Ethernet switches are connected to the backbone switch. Click Next to continue. A multi-protocol router operates at the network layer of the OSI model. It supports two or more communication protocols such as Internet Protocol, that is IP, and Inter-Network Packet Exchange, that is IPX. A multi-protocol router receives a packet on one port and forwards it to the next port. Click Next to continue. A router is a combination of a bridge and a router. Hence, it provides functions of both and can operate at the data link and network layers. Router connects networks which use different protocols. It can be programmed to work only as a bridge or only as a router. Click Next to continue. A Layer 3 switch is a high-performance inter-networking device which is used for network routing. It is a combination of traditional switches and routers and has improved software logic. It checks the received packets and makes routing decisions based on the source and the destination addresses. Click Next to continue. Printer connected to a hub does not print. Click Next to view the basic checklist you must follow while troubleshooting a network device, for example, printer. Follow these steps to troubleshoot the network device. Click Next to continue. In this lesson, you learned that repeater is basically a regenerator as it regenerates the signal. Repeater and hub are layer 1 devices and operate at the physical layer. A multi-port repeater is known as hub. Hubs are of 3 types: active hub, passive hub, and intelligent hub. Active hub regenerates the signal while passive hub does not. Bridge and switch operate at the data link layer of OSI model. Types of bridges are transparent, translational, and source route. A switch filters and forwards data to the destination. A router is an intelligent device which functions at the network layer. Click Next to continue. In this lesson, you learned that routers are of 2 types: static router and dynamic router. Routing protocols use routing algorithms to determine destination ports. Routing protocols are of 2 types: interior and exterior. Gateway is a networking device which converts only the data format. Backbone is a segment that connects other segments. Multi-protocol routers support more than one communication protocols. Router provides combinational functions of a bridge and a router. Layer 3 switch operates at layer 3, that is, network layer of the OSI model. Click Next to take a quiz. Welcome to the Installing Networks lab. In this module, structured cabling connects all the systems in an organized way and into a single unit. It integrates voice, data, video, and other management systems such as safety alarms and energy systems. The structured cabling system is not prone to any kind of interference and fluctuations. Click Next to continue. In this lesson, you will be able to explain the need of structured cabling, identify cables and different types of connectors, work with modular outlets, work with different types of cables, identify closets, conduits, and cable tray, install racks and manage cables. Click Next to continue. The cabling system installations are designed to support a predefined set of protocols and applications. The key components of a structured cabling system are the entrance facility, main equipment room, telecommunications closet, backbone cabling, horizontal cabling, administration and work area. Click Next to continue. Click the boxes to learn about each component of structured cabling systems. Click Next to continue. Click the boxes to learn about a few more components. Click Next to continue. The maximum TIA-EIA 568A horizontal cabling distance is 99 meters, which is rounded off to 100 meters. The breakup of this distance is 6 meters of patch cable, 90 meters horizontal cable routed in the wall, 3 meters of station cable. Click Next to continue. The backbone cabling distance depends on the type of cable being installed and also depends on its location. The ISO IEC 11801 is an international cabling standard published in 1995. It is based on the ANSI TIA EIA 568 cabling standard. Click Next to continue. When dealing with structured cabling, there are situations where you have to pull out the cables from some conduits and punch down the free end of the cable. Conduits are PVC or flexible plastic pipes used to organize the cables, or also used as a medium through which the cable can travel from one end to another. When pulling the cable from the conduits, the prerequisite elements required are fish tape. They are used to make the retrieval process of the wires from one end of the cabling easy. Twine. It is a thread made up of 2 or 3 smaller threads or strands twisted together. It is used to pull the cables or to tie the cables. Conduits. They are plastic or PVC channels that are used to carry wire from one end to another. They are helpful in arranging the cables in the cabling system. Scale and tape. This tool is used to measure the force that is applied while pulling the cable. The force that is applied should not be more than 25 lb. Patch panel. It is a panel of network ports contained together within a closet. The patch panel connects the network's computers to one another and to the outside lines that enable the connection to the internet or another LAN or WAN. Click Next to continue. To pull the Cat5 untwisted pair cable, locate the cable that has an RJ45 connector and yellow sleeve at one end. Never cut off the connector from the yellow end of any cable. Cut the leads from the free end of the cable as shown. Cut off approximately 3 inches length of cable from the end of the cable and set this 3 inches length of cable aside. Route the end of the fish tape through the conduit as shown. Use wire pulling lubricant to reduce friction on the tape and wire as they are pulled through the conduit. Fasten the free end of the UTP cable to the end of the fish tape as shown. Fasten the end of the roll of twine to the fish tape and tape the connection area with electrical tape. Pull the cable and twine through the conduit. Pull the fish tape back through the conduit, unrolling the cable and twine as necessary. Disconnect the cable and twine from the fish tape and roll the fish tape and set it aside. Pull the twine as necessary. Cut the twine to an appropriate length. After pulling the cable, plug the cables in the cable tester. Again, plug the other end of cable in the patch panel circuit board jacks. Turn the cable tester switch on and test the cable. If the LED glows, the cable is OK. Click Next to continue. The cable connectors are part of a cable which plugs into a port or interface to connect one device to another. Most connectors are either male, that has one or more exposed protruding pins, or female, that has holes in which the male connector can be inserted. Click Next to continue. DB15 connectors are useful for a wide variety of electronics projects. They are commonly used on electronic and computer equipment and are small in size, which helps the installer to carry the device anywhere while working on a project. Click Next to continue. BNC connector is used with coaxial cables or with the Ethernet system. The basic BNC connector is a male type mounted at each end of a cable. They are also used to connect to monitors, which increases the accuracy of the signals sent from the video adapter. BNC T connectors are female devices used for connecting two cables to a network interface card. A BNC barrel connector allows connecting two cables together. BNC crimpless connector uses screw-on section to hold the pieces together and is not as reliable as a connector with a good crimp. Click Next to continue. 210 patch plug is used to reduce the crosstalk. It uses pair-to-pair compensation layered contacts, and internal pair isolation to improve performance. The visibility after fitting the plug helps in matching termination position on the other end. Click Next to continue. To connect 210 patch plugs, take a Cat6 cable and cut 12 inches. Remove 2 inches of cable jacket from one end. Separate the wire pairs. Locate the portion of the patch plug that has the manufacturer's name on it. Route the cable tie through the holes of the plug cover and secure the cable in place. Cut off the excess flush to the tie latch as shown. Insert the wires into the appropriate channel as shown. Maintain the twists as close as possible. Cut off the wire ends flush with the front of the patch plug as shown. Line up the two patch plug halves and press them together until they snap into place. Place the patch plug in front of connecting block number 3. Make sure that the blue wire is positioned properly. Plug the patch plug onto the block. Click Next to continue. A UTP cable is the most common cable used in computer networking. It has a unique color code. The color coding makes it easier for the installer to identify each wire or pair of wires in the cable. The color coding helps the installer when the pairs of cables are connected but are not organized. The terms tip and ring in network and cabling are termed as plus wire and minus wire respectively. These terms are used to designate the polarity of each wire. Each wire pair has a short name for easy identification. The wires in the first pair are designated as T1 and R1. The second pair is T2 and R2, and so on. Click Next to continue. The EIA and TIA are two separate organizations that provide standards for the electronic and telecommunication industries. The table shown alongside describes the wire pairs and the color code with wire number in EIA standards. Click Next to continue. Most installers use this standard and are recommended by all. Pairs T2R2 and T3R3 carry the data. It is recommended not to use pairs T1R1 or T4R4 for voice. Instead, these pairs are to be used for spares or for future high-speed data requirement that might demand more than 2 pairs. Click Next to continue. The Institute of Electrical and Electronics Engineers, that is IEEE, has designed a standard called 10BASE-T, which is also called as Twisted Pair Ethernet. This standard uses a twisted pair cable with maximum length of 100 meters and operates at the speed of 10 Mbps. Click Next to continue. Tools are used in networking to work with wires or devices or to connect wires and devices to each other. The different tools used are punch-down tool, RJ45 crimping tool, coaxial cable crimping tool, pin crimping tool, and coaxial cable stripper. Click each image to learn about the tools. Click Next to continue. Cable is a medium that transfers information from one network device to another. The installation works in 3 stages. The cable should run from the central point to the room. Mount the wall plate and wire the ends of the cables into it. At the central point, wire the cable's end to the switch. Click Next to continue. Color coding is a system which makes use of different colors as per the different standards. This different color helps differentiate the cables that run through the entire network system. Patch cable and crossover cable can be differentiated based on color coding. Patch cable. It is used to connect dissimilar devices, example, PC to hub. It is a short lead which has connector on either ends. They are made of stranded wires which make them flexible. It connects one piece of the equipment to another directly. The patch cable color coding standards are shown in the table alongside. Crossover cables. It is used to connect similar type of devices, for example, a PC to PC or a hub to hub. The crossover cable connects the transmitter PC to the receiver PC. If one end is wired using the T568A standard and the other end using the T568B standard, then it is a crossover cable. Click Next to continue. Crimping means to connect a connector to the end of a cable. When you crimp a cable, make use of efficient tools to trim the ends of the cables. If an efficient tool is not used and you crimp it twice, then it will bend or flatten the pins. The tools and materials required for crimping cable are RJ45 crimping tool. Crimpers grip, turn, pull, or crimp a variety of things. The crimping die pushes 2 plungers on the RJ45 connectors. Plastic or wedge is forced onto the cable jacket, which prevents it from pulling it out of the RJ45 connector. Wire stripper. A wire stripper is a small handheld device which is used to remove the protective covering from the electric wires. It removes the protective covering without causing any damage to the conductors. The spring attached helps the handle for self-opening action. Wire cutter. Wire cutter is a handheld device which is used to cut large wires. The spring attached allows it to return to the self-opening action. It has PVC, that is polyvinyl chloride, hand grip for comfort. RJ45 plugs. RJ45 register jack is a physical connection which is used to terminate twisted pair type of cables. It has 8 pins per connector. It is used for Ethernet cables and networking services. As per the EIA-TIA standards, RJ45 is also used for RS-232 serial interface. Cat5 UTP cables. Cat5 UTP, that is unshielded twisted pair, is designed for reliability of high-speed signal. Electrical interference, which causes crosstalk, is reduced due to twisting available in the cables. These wires minimize the impedance mismatching at the connection points. Click Next to continue. RJ45 modular outlet is a device that is used to connect shielded or unshielded cables. It acts as an extension where the wires are fixed on one end and the other wire can be connected to the other end of the modular connector. To prepare RJ45 modular outlet using unshielded cable, take the RJ45 cable that you want to punch down to the modular connector. Strip off the outer insulation of the cable with the help of the crimping tool. Separate the wires which are tangled together. Separate the wires that are twisted together. Straighten and place the wires in correct order. Trim the wires to the required length. Open the stuffer cap of the modular outlet. Place the cable pairs with appropriate color code slots. Take a punch-down tool and punch the cables into the slots. Place the stuffer cap back onto the connector. Click Next to continue. Information outlets protect the horizontal wiring when the computer equipments are moved from one place to another. Information outlet has two additional connectors, one on the outlet and one on the mating station cable. Otherwise, that would run unbroken from the wiring closet to the node or from node to node. The connectors would range from the common RJ45 phone and LAN connectors to token ring and fiber optic attachments. The functionality of the modular units is unique. They snap in and out of the outlet frame. Due to this feature, configuring and modifying outlets is easy as per the organization needs. Click Next to continue. Cat5 cables are punched into information outlet as per the color coding. Crone tool is used to punch the cables into connectors. To connect the patch cable to the information outlet face plate, fix the information outlet to the appropriate place. Make the connection of the LAN cable on the other side of the information outlet board. Slide the slider upwards. Insert the cable inside. Click Next to continue. Jack panel is used to connect the horizontal cable to the network equipment. It is used when there are many computers that have to be connected to the network. Managing a lot of Ethernet cables becomes troublesome, and hence Jack panel helps the administrator by assigning numbers on the label for a specific cable from source to destination. Click Next to continue. To connect cable to jack panel, strip off the jacket from the cable. Place the wire pairs into the appropriate color-coded contacts. Punch the cable using punch-down tool as shown. Trim the excess wire, if any, with the help of a cutter as shown. Use cable ties to make sure that the cables are in place in the panel as shown. Click Next to continue. In straight-through cables, the pin-out connections are same at both the ends. These cables connect different types of devices. In the crossover cable, the pin-out connections are different at both the ends. These cables are used to establish a connection between similar types of devices. Click Next to continue. To create a straight-through cable, take the UTP cable that you want to create a straight-through cable. Strip off the outer insulation of the cable with the help of the crimping tool. Separate the wires which are tangled together. Separate wires that are twisted together. Straighten, place the wires in the correct order and trim them to the required length. Slide wires into the plug. Crimp the plug with the help of the crimping tool. Repeat steps 1 to 7 for the other end. Click Next to continue. A weak link in the networking system may cause the whole system to fail. The station cable is the weakest link in cabling system that runs from wall to the desktop. In a structured cabling system, UTP wire or fiber optic cable are used to link wiring closet and the network node. The electrical noise, high resistance, and crosstalk are generated from the information outlet and the associated cable connectors. The frequent source of problem are three pieces of the final link. They are the connectors on the information outlet, the connectors on the station cable, and the station cable itself. The connection between copper wires and a metal connector must comply with strict installation steps to reduce the weak link in the structured cabling. Click Next to continue. The station cable runs between the wall and the desktop. Station cables use stranded wire to improve the flexibility of the cable and its resistance to the breaks that can be caused by the metal fatigue. There are some configurations on the station cable which makes it an active part of the network. The figure shows the station cable equipped with a media filter which is used to connect an old token ring network interface card to unshielded twisted pair horizontal wiring. Click Next to continue. A patch cable, also known as patch cord, is a part of cable used to connect a computer, printer, or other device to a network. A patch cable can be made of both shielded twisted pair and unshielded twisted pair cable. Click Next to continue. To make a shielded patch cable, cut a Cat5 shielded cable, that is STP, of 14 inches length. Cut through the cable jacket for 1 inch as shown. Pull the jacket away from the shield as shown. Cut the slit portion of the jacket as shown. Find the overlapping portion of the shield and pull shield away from the wires. Click Next to continue. Cut it to the same length as the foil shield. Install the wires into a shielded RJ45 connector. Crimp the connector with the help of a crimper. Trim off the excess foil and drain lead of the rear of the connector. Click Next to continue. Plug the cable into the cable tester and test. To check the cable on multimeter, turn the multimeter to its lowest resistance range, that is 200 ohm. Plug the meter probes in the multimeter. Read the display and record the reading. This is open circuit reading. Touch the metal tip of the meter probes together and record the reading as shown. This is a short circuit or continuity indication. Make a continuity check between the shields of the shielded cable. Touch either meter lead probe to the metal portion of either shielded RJ45 connectors and the other meter lead to the metal portion of other RJ45 connector as shown. See the meter reading. The meter reading should be the same or nearly the same as the continuity test above. Click Next to continue. Grounding is a process of establishing a connection between the electrical equipment and the earth. The electrons flow from the negative source to positive source in the AC, that is alternating current, and DC, that is direct current system. To carry the flow of electrons, a complete circuit with two conductors is required. The transformer is used to reduce the high transmission voltage to the voltage that is used in consumer electronic equipment, that is 120 or 240 volts. The transformer can have several windings that feed separate legs of the electrical system. The transformer is your computer interface to the commercial power grid. Power system uses 3 wires. The 2 wires that come from the transformer are called the hot wires, usually red in color, and the neutral wire, usually black in color. The neutral wire is connected to an earth ground at the power plant and at the local transformer. High voltage persists between the LAN cable and the chassis of a piece of equipment. If a building has faulty ground wire connection to an outlet, fiber optic cable is the best option to link buildings and wiring closets on different floors because electricity does not travel over glass. Click Next to continue. Power grounding problems fall into 2 categories. They are open or high resistance ground or an abnormal pulse or condition between power conductors. An open power ground occurs when there is a poor installation, vibration that loosens connectors, or corrosion. A low-cost AC circuit tester can detect it. The tester measures the voltage difference between the neutral wire and the ground wire at an electrical socket. The tester does not detect signal ground problems. Click Next to continue. Closet is a main point in an organization where the major networking cabling comes together. The wiring hub in a small office would be hanging from the back of a desk or with the cables running directly to the LAN adapter in each node. However, the case would not be the same where there are more nodes. Patch panels for vertical and horizontal wiring, the wiring hubs, and uninterruptible power supplies are the equipments used in a wiring closet. The closet should be easily accessible and should be well secured. Each wiring closet is connected to a main cross-connect point. There are 2 types of wiring closets. Intermediate distribution frames, that is IDF. They are placed throughout the building and provide the connections to end devices. There is at least one IDF per floor for a multi-story building. Multiple IDFs are required for larger floor layouts to provide connection for all end devices. Main distribution frame, that is MDF. It is the main concentration point for an entire building or campus. It is the place where the inside cable plant meets the outside world's connectivity. All IDFs throughout a building are connected to the MDF in a star topology. Click Next to continue. The main area of concentration in the wiring closet is the backbone wiring cross-connect device, patch cables, a horizontal wiring cross-connect device, or wiring hubs and backup power for the wiring hubs. The wiring closet also has network portal devices such as a router, a cluster of modems, or an access server. The layouts for the equipments in a wiring closet are generalized in two approaches, on the wall or in an equipment rack. These approaches are sometimes combined by the installer and they put the cross-connect devices on the wall while keeping wiring hubs and other devices in an equipment rack. Click Next to continue. Cross-connect devices are useful when configuring horizontal and backbone wiring to add network connections and to replace bad wire pairs. They also terminate a cable or a group of cables and make it available for interconnection to other cables. They are of two types: punch-down block, patch panel. Click Next to continue. The patch panel and the wiring hubs inside the wiring closet can be mounted on the wall using racks or can be placed in cabinets. A distribution rack is a skeletal frame which comes between 39 and 74 inches high and holds 19-inch wide equipment panels. It makes handling of the equipment easy. Click Next to continue. UPS is a system designed to provide power immediately when the normal power supply has failed. The selection of the UPS depends on the power requirements of the equipment in the wiring closet. Click Next to continue. Conduits are plastic pipes that run through wall plate to the wiring closet and between the wiring closets. The advantage of conduits is that if there is space left in the conduit, it can be used to pull a new cable as a replacement for a bad one or for added capacity. Click Next to continue. A cable tray is a wire rack that is designed to hold the weight of the cables. They are used in spaces such as basements, air shafts, and ceiling. The use of the cable tray inside the wire closet controls the cascading of cables and help in distributing the cables to patch panels. Click Next to continue. Backbone wiring is also known as vertical wiring. UTP or fiber optic cables are used for the backbone. Each wiring closet contains patch and cross-connect panels that connect to the horizontal wiring and to the backbone wiring. The wiring closet also contains one or more wiring hubs for the appropriate network architecture. The TIA-EIA standards suggest that the backbone system should be a star configuration. The specification says that there should be separate backbone cables going from the main cross-connect point to each wiring closet. This type of configuration is helpful and expandable to a certain extent. Click Next to continue. A rack is a metal frame that has multiple holes and is used to house the different network equipments. Installing the rack explains how to place the networking equipment and accumulate different small equipments on the plate of the rack. By organizing the equipment on the rack, troubleshooting any problem becomes easy. When installing the rack, you have to determine different factors such as the location where the rack will be installed, marking of installation holes, installation of the rack nuts, and mounting of the different rails onto the rack. Click Next to continue. To connect computers to a network equipment on the rack, a patch panel is used. The patch panel is generally mounted on the rack and is used when there are many computers that have to be connected to the network. This facilitates easy management of the cables. After installing the patch panel, the cables running to the patch panel must be placed in proper position. They must be guided properly with the help of loops attached on the rack. The ports on the patch panel are numbered in order. Click Next to continue. There are various tools that are used to manage cables and wires that run from one point to another in the organization. The use of the wire managers is to manage the wires that are common to one place. The different tools used to manage wires are cable ties, conduits, twines, cable manager, labels, spiral wraps, and unitags. These tools help the administrator to manage the cables that are running from one point to another. Click Next. When the cables are labeled, you can identify the path of the cables. The distinct color and pattern of each cable label helps to identify the cables. The cable labels can be written on with a pen or a pencil, which is printed on a tough tear and fade resistant material. Click Next to continue. In this lesson, you learned that structured cabling interconnects different equipments in a structured manner. Cable connectors are used to connect the cables. Cabling tolls are helpful to make the connection between the cable and the connector. Color code helps to identify the types of wires. Cat5 cables are punched into information outlet as per the color code. Jack panel is used to connect horizontal cabling to network. Straight-through cables have pin-out connections similar at both ends. Click Next to continue. In this lesson, you learned that crossover cable changed the pin-out connections at one end. Installing the rack explains how to place networking equipment. Wire Manager organizes the disorganized cables for easier access. Labeling the cables helps to identify the path of the cables and in troubleshooting. Click Next to take a quiz. Welcome to the Installing Network. Wireless technologies allow one or more devices to communicate with each other without any physical connections such as cables. This technology has some advantages over wired networks like ease of setting up the network and freedom from cable connections. Click Next to continue. In this lesson, you will be able to identify wireless networking, compare wireless and wired network, explain the different wireless standards, list the components required for wireless networking, discuss the various applications of wireless networking, troubleshoot wireless network problems. Click Next to continue. Wireless communication is established using standard network protocols and without the use of cables. A wireless network can be established using two different ways. Click Next to continue. An access point can also be used to set up a wireless network. In this type of network, the wireless device connects to the access point and to the network. The access point acts as a hub to connect two wireless computers. The wireless network range can be extended by adding additional access points to the existing network. Click Next to continue. To set up an automatic wireless network configuration, click Start. Select Settings. Click Control Panel. Click Network and click Network Connections. Double-click Wireless Network Connection. Click the Wireless Networks tab and select the Use window. Click the Add button to configure a new wireless network. Enter an appropriate name in the Network Name SSID text box. Select the appropriate wireless network key settings. Click the Connection tab. Select the Connect when this network is in range checkbox. Click OK. Wireless networking is the latest networking technology. Wireless network has few more advantages as compared to the wired network. The chart shown alongside shows the comparison between a wireless and a wired network. Click Next to continue. A few more comparisons between a wireless and a wired network are shown in the chart alongside. Click Next to continue. Wireless technologies work as per the standards accepted worldwide. The important aspect of wireless standards is that devices of different manufacturers should be able to operate everywhere without the need of a specific standard. The different standards are shown in the figure. Click Next to continue. IEEE 802.11 specifies the standards used between a wireless client and a base station or between two wireless clients. Base station is a two-way radio installation used for communication with one or more wireless devices. The 802.11 standards mostly utilize the DSSS spread spectrum method. Click Next to continue. IEEE 802.11 has several standards. The wireless devices can communicate with each other only if they are using the same standard. The standards are IEEE 802.11, IEEE 802.11a, IEEE 802.11b, IEEE 802.11g, IEEE 802.11n. Click the boxes to learn about each IEEE 802.11 standard. Click Next to continue. The four methods of wireless network security are data encryption, port-based access control, service set identifier that is SSID, and media access control that is MAC address filtering. Data encryption secures the data that travels through the network and rest are for secure access to the network. Click Next to continue. The data packets are locked with a private encryption key before being transmitted, and the receiver must have the encryption key to unlock the packet and access the data. Two methods used are wired equivalent privacy and Wi-Fi protected access. Click the boxes to learn about each method. Click Next to continue. Data encryption secures the data that travels through the network. Three methods are used to secure the access to the network. Click the boxes to learn about each method. Click Next to continue. Wireless devices communicate with the help of radio frequency waves. The important components required for setting up a wireless network are access point, extension point, wireless bridges, power line bridges, antennas, wireless adapters, wireless station, and server. Click Next to continue. Wireless medium is an unguided form of networking medium. Signals are transmitted through air and space using radio and satellite networks. Wireless transmission uses Bluetooth, infrared, lasers, radio signals, and microwave technologies for data transmission. Lasers, infrared, and Bluetooth are used mainly in LAN environments, whereas microwave and other radio frequencies are used to connect vast geographical locations. Mobile computing allows you to connect to any network either using Bluetooth or radio frequencies. Refer to chapter number 3 for more details. Click Next to continue. An access point device is used to establish a connection between two or more wireless devices. It maintains data flow between a wired and wireless network. Access points are used to add a wireless extension to the network. They are of two types: hardware access points, software access points. Hardware access point is a physical device that is used to establish a connection between a wired network and a wireless network. Computer that includes the software acts as access point and helps the wireless network to communicate to the wired network. Click Next to continue. Extension points are used if a single access point is not able to cover the entire area. They act as wireless relays extending the range of wireless network. Multiple extension points can also be connected together to provide wireless access to devices far away from the main access point. Click Next to continue. Wireless bridge connects two or more wireless networks in a large home, across the street, or between two buildings. Bridges can be connected to the networks either through point-to-point or point-to-multipoint connections. Point-to-point bridges can communicate with a single bridge and can connect two wireless network segments. However, point-to-multipoint bridges can talk to more than one bridge at a time and are used to connect multiple network segments. Generally, bridges tend to operate with other bridges of the same type and model. Click Next to continue. Power line bridge is used to penetrate a wireless network when it is not possible to connect to the network. If it is difficult for the wireless router to reach the desired network, then a pair of power line bridges can be used to connect the router to an access point via the electrical wiring. Click Next to continue. Antennas are used to increase the range of the wireless network. While installing antennas, ensure that the antenna is compatible with the router, access point, or the adapter that you installed in the network. The two types of antennas used are omnidirectional antennas, directional antennas. Omnidirectional antennas are commonly used antennas in access points. These antennas are generally for indoor use, such as offices which have a small area. Omnidirectional antennas provide a 360-degree coverage area and are ideal for areas which are square or rectangle in shape. Directional antennas have a high gain and are used for long-range outdoor use. Directional antennas are used where high power is necessary to penetrate into the network. Click Next to continue. Wireless adapter cards help in connecting the computer or PDA to a network. The wireless adapters are available as PC cards, PCI and Mini PCI, USB, Compact Flash and SCSI device, that is SD. The adapter should be checked for compatibility with the operating system. They are also used with printers in a network. Click Next to continue. Wireless LAN consists of a wireless station and wireless server. Devices that can connect to the wireless network through a wireless medium are known as stations. The stations communicate with the help of wireless network interface cards. The stations are of two types: wireless clients, access points. Wireless server is the main server that is connected to the wired network, which in turn is connected to the access points. It is the main server which controls all the devices within the wireless network. Click Next to continue. A wireless network adapter requires two types of software to function properly: a driver and a configuration utility. Windows XP Professional has built-in drivers for many popular wireless NICs. However, it is better to use the drivers and configuration utilities provided by the vendor along with the wireless adapter. Along with the driver, you also need a utility for configuring the wireless hardware, which connects to other wireless devices. Windows XP has built-in tools for configuring these settings. Click Next to continue. Wireless technology is used to create different networks. Common wireless networks are Wireless Local Area Network, that is WLAN, Wireless Wide Area Network, that is WWAN, Wireless Personal Area Network, that is WPAN, Wireless Metropolitan Area Network, that is WMAN, and mobile computing. Click each box to learn about these networks. When done, click Next to continue. You may face problems while accessing a network. This problem may be due to incorrect or loose connections or loss of power supply. Troubleshooting wireless network adapter is same as troubleshooting any other hardware components. You need to follow few steps to troubleshoot the wireless adapter. Click Next to continue. Network performance reduces if the signal strength of the access point is low. There are various factors that make the signal low. To increase the strength of the signal, you need to try out some options. Click the boxes to learn about each option. Click Next to continue. Problems may develop in the wireless network if the operating system settings are not configured properly. These problems occur if the Dynamic Host Configuration Protocol, that is DHCP, encryption keys, MAC address filters, or SSID settings are not configured correctly. You need to check these settings. Click Next to continue. In this lesson, you learned that peer-to-peer and access point LANs are types of wireless networks. 802.11 standard defines all aspects of radio frequency wireless networking. Wireless network security methods: wired equivalent privacy, Wi-Fi protected access. Access is secured by SSID, MAC address filtering, and port-based access control. Microwave and radio frequency are the medium for wireless networking. Hardware and software access points are two types of access points. Wireless bridge is used to connect two or more wireless or wired networks. Click Next to continue. In this lesson, you learn that antennas are used to increase the range of the wireless network. Wireless adapter card helps to connect a computer to wireless network. Devices that can connect to wireless network are called wireless stations. Wireless server is the main server connected to the wired network. Click Next to take a
Welcome to the Configuring Networks Lab. Here you will learn about network servers, TCP/IP services and applications, WAN technologies, client-server system and remote connectivity. Click on a topic on the screen to continue. A network consists of more than one computer, each performing a particular task. A server is a computer that handles requests for data, email, file transfers and other network services from other computers. Typically, these computers are more powerful than ordinary computers and run on server software. Click Next to continue. In this lesson, you will be able to describe client-server and peer-to-peer network model, explain domain name system, explain dynamic host configuration protocol, explain Windows Internet Name Service, state the features of network operating system. Click Next to continue. In a client-server model, there can be only one server and one or more than one clients. The clients are connected to the server. This model consists of high-end servers which provide services to the clients as per their requests. A client-server model was used by the earlier network operating systems. As far as the clients are concerned, the only system on the network is the server. The clients cannot see each other and it is not possible for one client to access shared resources on another client system directly. It is necessary for the clients to save the data on the server so other systems can access it. Click Next to continue. In a peer-to-peer, that is P2P network, computers on the network act as both clients and servers. The computers in this network are able to communicate and share data with each other. The computers can access the shared data such as audio, video or text and hardware resources such as a hard disk or a CD drive. Access to the shared resources depends on the rights granted to the users. For example, if a user needs to access a printer connected to the other computer in a P2P environment, the user needs to have appropriate rights to access the printer. Access rights can be controlled by setting passwords. Click Next to continue. There are different tasks required to be performed in a network. Depending upon the nature of work, the servers can be classified into different types. Click each box to learn about server types. Click Next to continue. Click each box to learn about some more server types. Click Next to continue. Networking tasks also include sharing files and network resources such as printers and scanners. A user can also share an internet connection among multiple computers. To make folders available to other computers on the network, user must enable file sharing for the folders. Click Next to continue. Select the folder to be shared, for example, Network Essentials, and click File. Sorry, that's not right. Sorry, that's not right. You must click File. Sorry, that's not right. You must click File. Click Sharing and Security. Select the Share this folder option. Enter the share name and click OK. The file sharing procedure is Email server is often referred to as mail server. A mail server is an application that receives email from users on the local network, remote users, and forwards outgoing email for delivery to the intended users. Most email servers use Linux operating systems as they are less prone to viruses. Click Next to continue. Name resolution is the process of mapping computer names to their associated IP addresses. The names a user enters in the browser are converted into IP addresses so that the site can be accessed. There are two ways to resolve names: NetBIOS and DNS. Network Basic Input-Output System, that is NetBIOS, uses a flat namespace. In a flat namespace, two machines cannot share the same name. Flat namespace works well on a small isolated network, but not for a large organization, as it is impossible to check that all the systems have a unique name. Domain name system, that is DNS, uses hierarchical namespace. This technique uses a distributed database. TCP/IP applications use the distributed database to map host names to the IP addresses and IP addresses to host name in case of reverse name resolution. Click Next to continue. Internet domains are classified into various categories like root, or the topmost level of the Internet domain namespace. The top level domain lies beneath the root DNS domain as shown in the figure. There are three different categories of top-level domains. Organizational domain. Domain name that falls under this category are named using a 3-character code that indicates the functionality of the organization under that DNS domain. For example, .com. Geographical domain. Domain names are interpreted using the 2-character country or region codes, which are specified by ISO, that is International Standards Organization 3166. For example, .uk. Reverse domain. Reverse domain maps IP addresses to names. These domains are named as in-addr.arpa. Click Next to continue. A DNS zone is a contiguous part of a namespace for which a server has been assigned authority. Each zone is connected to a domain node. A DNS server contains information about the zones. A separate DNS server can be used to control each zone. Consider the figure shown alongside. The domain jetking.com has two subdomains, hr.jetking.com and sales.jetking.com. Authority for the hr.jetking.com, a complete DNS name including the host name and all its domains in order, is called a fully qualified domain name, that is FQDN. When a system needs to know the IP address for a specific FQDN, it queries the DNS. A DNS server is used to resolve a named Dynamic Host Configuration Protocol, that is DHCP, provides dynamic configuration of IP addresses. DHCP is mainly used for the Windows operating system. It provides all the information like the IP address, the default gateway, and the DNS address. DHCP reduces administration of a TCP/IP network. For example, consider a scenario in which you are using static IP addressing. Now, if you want to change the IP address of your default gateway, then you have to update the IP address of all the systems. This can be very time-consuming. However, if you use DHCP to provide the IP addresses dynamically, then DHCP would automatically update all the systems. Click Next to continue. DHCP is based on the common TCP/IP model of client-server operation. The client and the server have responsibilities and must send and receive messages. The DHCP server and client play complementary roles. The server maintains the configuration parameters for all clients, and each client maintains its own parameters. Click Next to continue. DHCP provides temporary IP addresses called the lease, which are valid for a particular amount of time. When the lease time expires, the host client either stops using the IP address or renews the lease. In such a situation, the server can either agree or disagree to renew the lease. DHCP specifies three methods to allocate IP addresses. Manual allocation. The server administrator manually assigns the IP addresses. Automatic allocation. An IP address is permanently assigned to the requesting client from a pool of IP address. Dynamic allocation. In this, a device can have different IP address every time it connects to the network. Click Next to continue. In DHCP, the DHCP server holds a collection of IP addresses which it can lend to the client stations as per the requirement. Whenever any client logs on to the network, the DHCP server assigns an IP address to the client for that time period. The server does not grant the same address to another client during this time. In the dynamic address allocation in DHCP, a client no longer owns an address, but rather leases it. When a client machine is set to use DHCP dynamic addressing, it is never assigned a permanent address. Instead, each time it starts, it must initiate its communication with a DHCP server to begin or confirm the lease of an address. DHCP leases follow a similar lease lifecycle, which generally consists of the following phases. Allocation. Initially, the client is not assigned an address. It acquires the lease through a process of allocation. Reallocation. If a client has an address from an existing lease and he reboots his computer, then it will contact the DHCP server for the granted lease to confirm the lease and acquire operating parameters. Normal operation. Once a lease is active, the client functions normally. The client is said to be bound to the lease and the address. Renewal. After a certain period, the lease expires. The client will attempt to contact the server that initially granted the lease to renew the lease. Rebinding. If renewal fails, then the client will try to rebind to any active DHCP server and try to extend its current lease with any server that will allow it to do so. Release. The client may decide to terminate the lease as required and release the IP address. Click Next to continue. WINS is used to map network basic input-output system, that is NetBIOS computer names, to their corresponding IP addresses. WINS was created to resolve the problems of broadcast-based name resolution. In broadcast-based name resolution, hosts broadcast messages to all other nodes to resolve NetBIOS names to IP addresses. Broadcast-based name resolution increases traffic in large networks. The WINS server is used to reduce overhead from broadcasts and to allow NetBIOS name resolution across routers. WINS also uses a hierarchical naming system and depends on special WINS server software. The client computers first register with the WINS server when they log on to a WINS network. The server puts the client's NetBIOS name and IP address into its WINS database. Any system on the network can then query the WINS server for NetBIOS name resolution. Click Next to continue. Click each box to learn about different stages of WINS. Click Next to continue. To configure WINS in Windows XP, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Select Internet Protocol, that is TCP/IP, and click the Properties button. Click the Advanced button. Click the WINS tab. From the WINS address, in order of use group, click the Add button. Enter the primary WINS server address in the WINS server text box and click the Add button. Select the Enable NetBIOS over TCP/IP option. Click OK. Most WINS problems are not directly related to WINS, rather they are related to NetBIOS. The most common problem is two systems with the same name. In such a situation, you receive an error message. To fix this error, change the name of the system. NBT-STAT is used to troubleshoot NetBIOS name resolution problems. It will do a number of jobs depending on the switches you add at the end of the command. The NetBIOS name cache contains the NetBIOS names and corresponding IP addresses that have been resolved by a particular host. Click Next to continue. NBT-STAT is used to troubleshoot NetBIOS name resolution problems. To execute NBT-STAT command, select Start and click Run. In the Run dialog box, enter CMD. Type NBT-STAT space -A builder. Click Next to continue. Network Operating System, that is NOS, is meant for computers that can be connected to a network. A NOS provides protocols, device drivers, and support for multiprocessing applications. It supports internetworking features such as routing. NOS organizes the activities of multiple computers across a network. Click Next to continue. A file sharing component is installed in each client machine that interacts with the server to share files and applications as well as network devices such as printers, faxes, and modems. There are several types of network operating systems. Click each image to learn about network operating systems. Click Next to continue. In this lesson, you learned that in client-server model, the server controls the clients in the network. In P2P network, all the PCs act as both clients and servers. Name resolution maps computer names to their associated IP addresses. Domain name system maps fully qualified domain names to IP addresses. DHCP protocol is used by clients to obtain IP addresses automatically. DHCP provides a temporary IP address with a particular lease time. WINS maps NetBIOS computer names to corresponding IP addresses, configuring and troubleshooting WINS. Network operating system handles concurrent requests from clients. Click Next to take a quiz. Welcome to the Configuring Networks lab. Transmission Control Protocol, Internet Protocol, that is TCP/IP services, are client-server applications that use the TCP/IP protocol as their communication mechanism. These services are based on application layer protocols that provide information for delivery by TCP/IP. An example is the electronic mail service provided by TCP/IP. Click Next to continue. In this lesson, you will be able to explain Simple Mail Transfer Protocol, that is SMTP, explain Hypertext Transfer Protocol, that is HTTP, explain File Transfer Protocol, that is FTP, explain Trivial File Transfer Protocol, that is TFTP, explain Network News Transfer Protocol, that is NNTP, explain and configure Simple Network Management Protocol, that is SNMP, explain Post Office Protocol, that is POP, explain Internet Message Access Protocol, that is IMAP. Click Next to continue. In this lesson, you will be able to explain electronic mail, explain BootP and DHCP, explain Telnet, explain World Wide Web, that is www. Click Next to continue. SMTP is an Internet Standard Protocol that is used for transferring email from an email client to a server and from a mail server to another mail server. It specifies how the mail systems work together and the format of control messages they use to exchange and transfer mail. A two-way transmission channel is established between the sender SMTP and the receiver SMTP. To provide the sending and receiving capability between the server and the destination host, the SMTP server must be supplied with the name of the destination host as well as the name of the destination mailbox. The steps are as follows. SMTP sender sends a mail command. SMTP receiver accepts mail command and responds with an OK reply. SMTP sender sends a RCPT command identifying the recipient. SMTP receiver accepts mail for that recipient and responds with an OK. Click Next to continue. The Hypertext Transfer Protocol, that is HTTP, works on the request and response between the client and server. A HTTP transaction can be explained as follows. The client sends a request to the server asking for data. The server processes the request and sends the appropriate response to the client. Click Next to continue. Uniform Resource Locator, that is URL, FTP is used over the internet to exchange files. FTP uses the internet's TCP/IP protocols to enable data transfer. The user can download a file from a server or upload a file to a server using FTP. This technique solves problems related to file transfer between computers. FTP establishes two connections between the computers. One connection is used for transferring data and the other for sending control information such as commands and responses. This separation between commands and data transfer makes the FTP operation more efficient. The client has three components, namely the user interface, client control process, and the client data transfer process. The server consists of the data transfer process and server control process. The control connection is made between the control processes, and the data connection is made between the data transfer processes. During the entire FTP session, the control connection remains on. This connection is established when the user starts an FTP session. For each file transferred between the client and the server, the data connection is opened and then closed. Two machines, a client that is a local host machine and a server that is a remote host machine, are involved in an FTP transaction. The client always initiates the data transfer. To copy files from the server to client, GET command is used. The PUT command is used to copy files from the client to the server. Click Next to continue. To view the files and folders on FTP using the command prompt, select Start. Click Run. In the open box, enter CMD and click OK. Type ftp moneymaker.com and press Enter. Type username and press Enter. Type password and press Enter. Enter the dir command and press Enter. TFTP is used to transfer files to and from a remote computer such as diskless workstations. Diskless workstations do not have their own storage disk and boot from a network host or server. When diskless workstations start up, they are unable to read the TCP/IP implementation from a hard disk. The process of transferring a file consists of three phases. Initial connection. TFTP client requests the server to establish connection. Data transfer. Data transfer is initiated between the client and the server. Connection termination. The connection is terminated when the last TFTP message has been sent. In the TFTP communication, the client and server exchange data and acknowledgement messages in lockstep way. One device sends data messages and waits for acknowledgements. The other sends acknowledgements and waits for data messages. Click Next to continue. Network News Transfer Protocol, that is NNTP, is a standard protocol used to transfer Usenet news from one machine to another machine. Usenet News is a large collection of discussion groups covering a wide range of topics. NNTP provides connection-oriented service. Click Next to continue. To configure news account that is NNTP in Outlook Express, click Start. Select All Programs. Click Outlook Express. Click Tools. Click Accounts. Click the Add button. Sorry, that's not right. You must click News. Sorry, that's not right. You must click News. Enter name for the news group in the display name text. Sorry, that's not right. You must click Next. Enter the appropriate email address for the account in the email address field. Click Next. Enter the name of your internet news server in the news that is NNTP server text box. Click Next. Click the Finish button. What does SMTP stand for? Select the correct answer and click Submit. SNMP enables network management applications to remotely monitor other devices on the network. It gives smart devices such as routers, switches, and individual PCs the capability to report their status and allow the administrators to make changes. SNMP is a framework for managing devices over the Internet. The SNMP uses two protocols to manage tasks. These are Structure of Management Information, that is SMI, and Management Information Base, that is MIB. SNMP defines the format of the packet that is exchanged between the manager and the agent, and vice versa. The agent maintains the MIB database. SMI is a protocol that defines the rules for naming an object and defining the type of the object. It only defines these rules and does not define how many objects are managed in an entity or the types used by the object. SMI does not make the association between the object and the type. MIB creates a set of objects for each entity that is similar to a normal database. This information is organized hierarchically. The role of MIB is to define the number of objects, name the objects with respect to the rules that are defined by SMI, and then associate a type to the named object. Click Next to continue. To install the SNMP service in Windows XP, click Start. Click Control Panel. Click Add or Remove Programs. Click Add Remove Windows Components. Sorry, that's not right. You must click Add Remove Windows. Select the Management and Monitoring Tools checkbox. Click the Finish button. To configure the SNMP service, in Control Panel, click Performance and Maintenance. Click Administrative Tools. Double-click Computer Management. In the console tree, expand Services and Applications. Click Services. In the right pane, double-click SNMP Service. Click the Agent tab. Enter the name of the user or administrator of the computer in the contact text box. Enter the physical location of the computer in the location. Post Office Protocol version 3, that is POP3, is an application layer Internet Standard Protocol used to retrieve email from a remote server to a local client over a TCP/IP connection. The design of POP3 supports end users with periodic connections such as dial-up connections that allow the users to retrieve email. POP3 is a TCP/IP client-server protocol. To provide access to the mailbox, the POP3 server software should run continuously on the server where the mailboxes are located. To get mail, POP3 clients establish connections with the POP3 servers. The POP3 connection is activated when the TCP connection is established. A POP3 session progresses through 3 stages, which are known as session states. POP3 is described in terms of a finite state machine, that is FSM. The 3 states through which the session transition takes place are authorization state, transaction state, update state. The session goes through each state only once. In the authentication state, the server requests the client to initiate commands. This tells the client that the connection is ready and that it can send the first command. The client who is trying to access a mailbox is now required to authenticate the user. The POP3 session transits to the transaction state only if the authentication is successful. In this state, the client is allowed to perform various operations on the mailbox. These include listing and retrieving messages and marking the retrieved messages for deletion. The session enters the update state automatically when the client finishes all the email message access and retrieval transactions and issues a quit command. This command has no parameters and tells the POP3 server that the client no longer requires the session and wants to end it. Click Next to continue. IMAP enables the users to work with the mail on the server. It does not download the mails. It is a standard protocol that is used to access emails from a remote server. The user can get new messages, delete messages, and perform search functions on mails. The user can store messages in folders and share mailboxes. Advantages: IMAP is the best option to access more than one account from different locations. IMAP allows simultaneous access by many users to the mailbox. User can retrieve portions of either individual parts or the entire message. IMAP user can create, rename, delete mailboxes, and move messages between mailboxes. Disadvantages: IMAP is more difficult and prone to error than POP3. IMAP results in higher server loads than POP3, which results in higher costs for the internet service providers, that is ISPs, and end users. Searching through mailboxes containing many emails utilizes a lot of server resources. Electronic mail or email is a technique using which a computer user can exchange messages with other computer users or groups of users via a communication network. The basic structure of a mail delivery system consists of a number of agents. Mail User Agent, that is MUA. The Mail User Agent is a computer program or software used by the client to send and receive email. Sending mail. The user needs to provide the message, the destination address, and other parameters while sending an email. The message can be developed using the text editor provided by the user agent or with the help of third-party software. Receiving mail. The user agent or UA at the recipient end checks the mailbox periodically for new email. If a UA receives a mail, a notification is given to the user. If the user is ready to read the mail, a list is displayed. The list contains information about the emails in the mailbox. Mail Transfer Agent, that is MTA. The Mail Transfer Agent is also called a mail server or mail exchange server. Mail server is a computer application that routes or transfers electronic mail from one computer to another. MTA identifies and analyzes the recipients and delivers the message to the destination. Click Next to continue. The email architecture defines the way in which an email system works and how it is organized. An email system is divided into two subsystems: User Agents UA and Message Transfer Agent MTA. The user agent reads and sends emails, and the message transfer agent sends messages from the source to the destination. The email architecture supports 5 basic functions. Composition. It defines the creation of the message and provides addressing assistance. Transfer. It defines the movement of the message from sender to recipient. Reporting. It signifies that the message status has to be sent to the sender. Displaying. The delivered message has to be displayed. Third-party software may be used to view the message. Disposition. The recipient may discard the message before or after reading or save it for later use. Click Next to continue. A computer needs to know its IP address before communicating on a TCP/IP network. A network host, if provided with an internal disk, can read this information from its internal disk. However, not all the hosts in a network have an internal storage. They need another device on the network to provide them with an IP address. To solve this issue, the TCP/IP bootstrap protocol, that is BootP, was created. Bootstrapping provides the host with the capability to get its IP address. BootP is a client-server protocol. The operation of BootP consists of exchange of the messages between a BootP client and a BootP server. Bootstrapping has 2 phases. In the first, the client is provided with an address and other required parameters. In the second, the client downloads software that lets it function on the network. BootP deals with the address assignment and configuration. The second takes place using TFTP. Click Next to continue. DHCP is an advanced version of BootP. It is built using BootP as a foundation, with message format being the same. DHCP can dynamically assign IP addresses to clients and centrally manage them. Due to these qualities, DHCP is the standard TCP/IP host configuration protocol and is used extensively. A collection of IP addresses is used to dynamically allocate addresses. This allows IP addresses to be efficiently allocated and can be shared amongst devices. DHCP also supports static mapping of addresses for devices when needed. DHCP massively reduces the administration of a TCP/IP network. Click Next to continue. The main difference between DHCP and BootP is that DHCP is mainly used by Windows networks and BootP is mainly used for diskless workstations. BootP. To establish connection to the server using Telnet, select Start. Click Run. In the open box, enter CMD and click OK. Type Telnet and press Enter. Type Live IP to establish connection to the server and press Enter. Type username and press Enter. Type password and press Enter. Enter executable commands. The World Wide Web, that is WWW, is a network of internet servers which support documents that are developed using HTML. Hypertext Markup Language, that is HTML, is a language in which these documents are formatted. HTML supports links to other documents, graphics, audio and video files. You can navigate from one document to another simply by clicking on the links provided. By entering an URL in the web browser, the user can find the HTML document. The address that is typed on the web browser helps the browser locate the HTML document on a remote computer. Click Next to continue. The operations that are performed by the client in a client-server relationship are called client-side, and the operation that is performed by the server in the same relationship is called server-side. Click the various boxes to learn more. When done, click Next to continue. HTML is a markup language that is used to create web pages that has information and multimedia to be displayed on a web browser. It is called a markup language because it has codes that are used to help lay out and style the document. HTML allows describing the structure of information such as headings, paragraphs, and lists. Markup language contains explicit commands to format data. Introduction of these commands within HTML file helps web browsers to read and reformat any web page. A web page consists of HTML tags, which are also called as standalone and container tags. Standalone tags are tags that do not have a closing tag, and container tags have a closing tag. Some of the HTML tags used in a web page are shown in the figure. Click Next to continue. The World Wide Web, that is WWW, contains a large amount of information on each and every subject. Search engines are used to search information or web documents on the WWW by using keywords or phrases. They break down the search into two categories, namely directories and indexes. Click Next to continue. In this lesson, you learned that SMTP specifies how mail is transferred from one host to another host. HTTP is a set of rules used for exchanging files on the World Wide Web. FTP is used to exchange files between hosts over the network. TFTP is used to transfer files to and from a remote computer. SNMP manages devices that are connected to the internet using TCP/IP. POP3 retrieves emails from a remote server to a local machine. IMAP enables users to work with mail on the server. Click Next. In this lesson, you learned that IMAP does not download the mail. Email is an abbreviation for electronic mail. Email is used to communicate over the internet. BootP and DHCP set the TCP/IP settings automatically for a client. Telnet is a terminal emulation program used to access remote systems. WWW is a network of internet servers supporting HTML documents. Click Next to take. Welcome to the Configuring Networks. Internet is an interconnected system of networks that connects computers around the world. Mostly, it uses the TCP/IP protocol for communicating between the computers. A web browser called Internet Explorer is used to view the contents on the Internet. Click Next to continue. In this lesson, you will be able to describe router, explain network address translation, that is NAT, explain proxy servers, configure TCP/IP, configure Internet Explorer, configure MS Outlook and Outlook Express, configure DHCP and DNS. Click Next to continue. In this lesson, you will be able to explain host names and FQDN, configure NetBIOS, troubleshoot DHCP and DNS, explain the applications of Internet. Click Next to continue. Router is an internet working device used to link two different networks. It determines the route through which the information will travel from source to destination in the form of data packets. There are two types of routers, static and dynamic. Click Next to continue. Network address translation, that is NAT, is a method in which a system's IP address is changed into a different IP address before it's sent out to an external network, that is Internet. In the figure, there is a NAT server. It is connected to a local intranet on one side and to the Internet on the other. It converts the internal IP address 192.168.42.1 to a single external IP address 210.15.123.25. The NAT thus allows address hiding, acts as a firewall, and enhances security of an internal network. Click Next to continue. In static NAT, a private, that is internal network IP address is converted to a static, which always remains same, public IP address. An internal network IP address is mapped to a registered IP address on one-to-one basis. Static NAT is useful when a computer is required to be accessed from outside the network. The figure shows that in static NAT, the computer with the IP address of 192.168.42.25 would always transform to 210.15.123.103. In dynamic NAT, a private address corresponds to a public address which is taken from a group of registered IP addresses. Dynamic NAT allows a private network to use private IP addresses that are invalid on the Internet. The figure shows that in dynamic NAT, the computer with the IP address of 192.168.42.25 would transform to an available range of IP addresses, that is 210.15.123.102 to 210.15.123.109. Click Next to continue. Proxy server is a computer that allows network users to make an indirect network connection to different network services. A client connected through a proxy server sends a request for a connection, file, or other resources provided by other servers. The proxy server then responds to the client's request by either connecting to the specified server or by providing the resources present within the cache of the proxy server. Click Next. The three types of proxy servers are transparent proxy server, reverse proxy server, and anonymous proxy server. Click the various boxes to learn more. When done, click Next to continue. To communicate with a proxy server, user needs to configure a client computer. NAT requires a subnet from the Internet Service Provider, which can be expensive. Click Next to continue. To configure a proxy server in a client computer, open Internet Explorer and select Tools. Click Internet Options. Click the Connections tab. Click the LAN Settings button. Select the Use a Proxy Server for your LAN. Enter the appropriate address of the proxy. Click OK. Transmission Control Protocol Internet Protocol, that is TCP/IP, is a collection of networking protocols widely used on the Internet. There are some basic TCP/IP configuration parameters like hostname, DHCP client, IP address, domain name, broadcast address, and default gateway. Click the various boxes to learn more. When done, click Next to continue. To configure TCP/IP for a DHCP client, open the Internet Protocol, that is TCP/IP Properties dialog box. Click the Obtain DNS Server Address Automatically option and click OK. Click Next to continue. To configure a dial-up connection on Windows XP, click Internet Options. Click the Connections tab. Select the required dial-up connection. Select the Automatically Detect Settings checkbox. Click OK. Internet Explorer Security Settings feature allows the user to protect the system from unsafe websites by storing them in different zones. The 4 zones that are available in Internet Explorer are Internet Zone, Local Intranet Zone, Trusted Site Zone, and Restricted Site Zone. Click the various boxes to learn more. When done, click Next to continue. You can add a web page to a particular security zone, for example, Restricted Site Zone, depending on your needs. To add a web page to the security zone, open Internet Explorer and select Tools. Click Internet Options. Click the Security tab. Select Restricted Sites and enter the website name in the Add this website to. Click OK. Click OK. Meta refresh HTML tags are used to redirect to the changed URL of the website by entering the old URL in the address bar. To enable the meta refresh setting, open Internet Options and click the Security tab. Select the required web content zone from the Select a Web Content Zone to specify its security settings group box and click the Custom Level button. Select the Enable option from the Allow Meta Refresh section and click OK. Click the Yes button. Click OK. Microsoft Outlook is a software. Select All Programs. Select Microsoft Office. Click Microsoft Office Outlook to click Tools. Click Email Accounts. Select the Add a New Email Account option and click the Next button. Select the POP3 option and click the Next button. Enter the required information and click the Next button. Click the Finish button. The email account in Outlook Express provides email and newsgroup functionality. To create an email account in Outlook Express, select Start. Select All Programs. Click Outlook Express. Click Tools. Click Accounts. Click the Add button. Click Mail. Enter the required display name. Enter the required email. Select the required mail server. Enter the incoming mail server name or IP address in the incoming mail, that is POP3, IMAP or HTTP server box. Enter the outgoing mail server name or IP address in the outgoing mail, that is SMTP server box, and click the Next button. Enter the required account name and password information and click the Next button. Click the Finish button. To configure a DHCP client, open Local Area Connection Properties dialog box. Select the Internet Protocol, that is TCP/IP checkbox, and click the Properties button. Select the Obtain an IP address automatically option. In case if the DHCP server cannot assign an IP address, click the Alternate Configuration tab. Enter the appropriate information and click OK. To configure a DNS client, open the Internet Protocol, that is TCP/IP Properties dialog box, and select the Use the following DNS server addresses option. Now, enter the IP addresses of the preferred DNS server, the alternate DNS server, and click OK. Click Next to continue. A host name is the unique name by which a computer is identified on a network. On a LAN, a host, a complete domain. Network Basic Input-Output System, that is NetBIOS, is a program that permits applications on different PCs to communicate within a local area network. To install NetBIOS NetBEUI on Windows XP, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Click the Install button. From the Click the type of network component you want to install list, select Protocol. Click the Add button. From the Network Protocol list, select NWLink IPX SPX NetBIOS Compatible Transport Protocol. Click OK. Double-click the NWLink IP SPX NetBIOS Compatible Transport Protocol option. If the user wants to execute file and print services, the internal network number should be entered. Click OK. Automatic Private IP Address, that is APIPA, is used by clients which are unable to access the DHCP server. APIPA allows the DHCP clients that cannot find a DHCP server a chance to access the server by giving them an IP address in the 169.254/16 network. Click Next to continue. To renew the IP address, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type ipconfig/renew. To release the IP address, in the command prompt, type ipconfig/release. Click Next to continue. Before troubleshooting DNS, it is necessary to remove any DNS cache on the local system. To remove DNS cache, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type ipconfig/flush DNS. Click Next to continue. To determine the IP address associated with a single host name by using NSLOOKUP, select Start and click Run. In the Run dialog box, enter CMD. Then in the command prompt, type NSLOOKUP followed by a fully qualified domain name. Click Next to continue. To resolve DNS problems, open Local Area Connection Status dialog box and click the Properties button. Select Internet Protocol, that is TCP/IP, and click the Properties button. Select the Obtain DNS Server Address Automatically option and click OK. Click Close. Click the Support tab. Click the Repair button. Click the Close button. Click the Details button. Verify the network connection details and click the Close button. Internet is basically a network of networks. Web pages are viewed in the web browser, that is Internet Explorer, through Internet. The Internet has numerous applications. Click the various boxes to learn more. When done, click Next to continue. In this lesson, you learned that router is an internetworking device used to link two different networks. NAT translates system IP address to a public IP address. Proxy servers enhance the security for the user accessing the internet. TCP/IP is a collection of networking protocols widely used on Internet. Internet Explorer, that is IE, is the most widely used web browser. MS Outlook acts as a personal information manager and offers email service. Click Next to continue. In this lesson, you learned that Microsoft Outlook Express is an email and news client. In DHCP method, an IP address can be allocated to a PC on boot process. Individual computer names are called as host names in a network. A complete DNS name, including host name and its domains, is called FQDN. NetBIOS permits applications on different PCs to communicate within a LAN. The Internet has numerous applications such as www, email, FTP, and Telnet. Click Next to take a quiz. Welcome to the Configuring Networks lab. Wide Area Network, that is WAN, is a type of network that covers a large geographical area. It consists of two or more local area networks, that is LANs, which allow users or computers at different locations to communicate with each other. The most common example of WAN is the Internet. WAN services are provided by different technologies such as circuit switching, packet switching, X.25 protocol, frame relay, asynchronous transfer mode, that is ATM, integrated services digital network, that is ISDN, and fiber distributed data interface, that is FDDI. Click Next to continue. In this lesson, you will be able to explain the types of network switching, explain the public switched telephone system, explain point-to-point WANs, describe the X.25 protocol, explain frame relay, explain ATM, explain the ISDN protocol and BISDN, explain the FDDI protocol, explain satellite communication. Click Next. Switching is a process of moving data through a series of intermediate steps, rather than moving from the start point directly to the end point. WAN uses three types of switching: circuit switching, message switching, packet switching. Click Next to continue. In circuit switching, a direct physical temporary connection is established between the sender and the receiver. In figure, the sender, that is computer A, wants to send data to the receiver, that is computer B. Thus, a direct physical temporary connection is established between them before the transmission occurs. The data is now transmitted over the connection. When the data transmission is over, the connection is released by the sender. The drawback of circuit switching is that the unused transmission is wasted, as the connection is reserved only for the two communicating parties. Click Next to continue. In message switching, the message to be sent is routed through intermediate nodes or stations, such as a central network computer, to reach the intended receiver. In figure, one computer in network 1 wants to send message packet to another computer in network 2. Here, a direct physical connection is not established. Hence, the message is passed through the intermediate nodes. Each intermediate node accepts the entire message, checks the address, decodes it, and then forwards the message to the next node. The sender can terminate the transmission after addressing it appropriately whenever it wants. Click Next to continue. In packet switching, the message to be transmitted is broken into small units called packets. In figure, a computer in network 1 wants to send a message to a computer in network 2. The message is first broken into smaller parts known as packets. In other words, the network 1 performs multiplexing of the packet. Each packet contains addressing information which identifies both the source and the destination nodes. These packets are then routed through the intermediate nodes known as packet switching exchanges, that is PSEs. Each node decodes the destination address in the packet and forwards the packet to the next node until they reach the destination. The packets are again demultiplexed to form the message. This way, using packet switching, the message travels from source to destination. Click Next to continue. The telephone system that uses copper wires to carry analog voice data is called the Public Switched Telephone Network, that is PSTN. The services carried by PSTN are bidirectional services, ringing signals and dial tone services, and operator services. Click the various boxes to learn more. The telephone system consists of the following three major components: local loops, analog twisted pairs going into houses, switching offices. Calls are moved from one trunk to another from here. Trunks, digital fiber optics used to connect switching offices. A typical circuit route for a medium distance call is shown in the figure. There are two telephones at different ends. The two copper wires of the telephone are directly connected to the telephone company's nearest end office. This end office is also called as local central office. The wired connection between the telephone and the end office is known as a local loop. Call is made from one telephone to another. The call first reaches the telephone company's end office. Each end office has a number of outgoing lines to one or more nearby switching centers. The switching center is known as a toll office. From the end office, the call is forwarded to the switching center. The lines connecting the end office and the toll office are known as the toll connecting trunk. Different tolls communicate with each other using the high bandwidth inter-toll trunks. According to the number and the appropriate area, the call is routed to the next toll office, which is nearest to the destination telephone or the receiver. It is then forwarded to the end office and finally reaches the destination telephone. Click Next to continue. There are two basic varieties of wireless telephones as follows. Cordless phones, used within the home and consist of a base station and a handset. Mobile phones, used for wide area voice and data communication. Click Next to continue. Mobile phones have gone through three distinct generations as follows. First generation, that is analog voice. Second generation, that is digital voice. Third generation, that is digital voice and data. Click the various boxes to learn more. When done, click Next. Point-to-point is a wide area network in the internet. Two remote devices connected using a line available from a public network is called as a point-to-point WAN. Services are basically provided at the physical layer, whereas the users are responsible for the data link layer protocols. Click Next to continue. The point-to-point connection between two devices at the physical layer can be accomplished using one of the following services. Click the various boxes to learn more. When done, click Next to continue. The data transfer at the data link layer may or may not be reliable. Thus, a protocol is needed at this layer to have a reliable point-to-point connection. The most common protocol for this purpose is the point-to-point protocol, that is PPP. All remote access softwares come with the PPP. It allows a computer to connect to the internet through a dial-up connection. PPP is superior to Serial Line Internet Protocol, that is SLIP, which is used by Unix because of its error detection and data compression feature. PPP supports any of the protocols recognized by American National Standards Institute, that is ANSI, such as Link Control Protocol, that is LCP, and Network Control Protocol, that is NCP. Click Next. X.25 is a connection-oriented packet switching protocol, which defines the way in which the connections between the user devices and the network devices are established and maintained. It is most commonly used in the packet switch networks, that is PSNs, such as the telephone companies. The recent X.25 protocol defines an interface between a host and a public data network, that is PDN, over a dedicated leased line circuit which reduces errors. The X.25 network devices are data terminal equipment, that is DTE, end devices that communicate across the X.25 network, such as terminals or network hosts in the subscriber premises. Data circuit terminating equipment, that is DCE. Communication devices such as modems, which provide an interface between DTE devices and a PSE. Packet switching exchange, that is PSE, transfers data from one DTE device to another through the X.25 network. Click Next to continue. A virtual circuit is a logical connection between the two network devices which ensures a reliable communication between them. Multiple virtual circuits can be multiplexed into a single physical circuit at the sending end and demultiplexed at the remote end to transmit the data to their appropriate destinations. In figure, the source host wants to send data to the destination host. The data is multiplexed at the source and is then passed through the virtual circuits. Finally, it reaches the destination host where it is demultiplexed. The X.25 virtual circuits are of two types: switched virtual circuits, that is SVCs, permanent virtual circuits, that is PVCs. Click Next to continue. Frame relay is a high-performance WAN protocol which operates at the physical and the data link layers of the OSI reference model. It has digital transmission capabilities such as a fiber optic cable and ISDN. Frame relay does not involve the error correction and the network flow control operations. Information transmitted over the frame relay network is in the form of variable length packets. The devices attached to the frame relay WAN for the transmission of data packets are data terminal equipment, that is DTE, and data circuit terminating equipment, that is DCE. Click Next. Frame relay virtual circuit is a logical connection that is established between the two data terminal equipment, that is DTE devices, over a frame relay packet switch network, that is PSN. Virtual circuit provides a bidirectional communication path between the DTE devices. The data link connection identifier, that is DLCI, uniquely identifies the virtual circuit that passes through a number of intermediate devices in the frame relay PSN. Click Next. Frame relay virtual circuits are classified into two types, such as switched virtual circuits, that is SVCs, and permanent virtual circuits, that is PVCs. Click the various boxes to learn more. When done, click Next to continue. A private frame relay network implementation is to provide a T1 multiplexer with frame relay and non-frame relay interfaces. T1 multiplexer combines digital input signals into one high-speed output signal. The frame relay traffic is forwarded out of the frame relay interface and onto the data network. The non-frame relay traffic is forwarded to the appropriate service or application such as telephone service or video teleconferencing application. The frame relay networks provide services to the customers, which is also called the public frame relay service. Frame relay is implemented to provide service for private enterprise networks and is implemented in public carrier provided networks and private enterprise networks. Click Next to continue. Asynchronous transfer mode, that is ATM, is a cell switching and multiplexing technology which combines the benefits of both circuit switching and packet switching. ATM transmits data, voice, and video signals simultaneously over the same communication lines. Click Next to continue. ATM transmits information in the form of fixed-sized units called cells. The ATM network consists of two devices which handles the transmission of cells over the network. Click the images to learn more. Click Next to continue. An ATM network is made of a set of ATM switches which are interconnected by point-to-point ATM links or interfaces. ATM switches use two types of interfaces for interconnection. User Network Interface, that is UNI, connects ATM end systems to an ATM switch. Network-to-Network Interface, that is NNI, connects two ATM switches. The UNI and NNI are classified on the basis of whether the switch is owned and located at the customer's premises or are publicly owned, that is located outside customer's premises and operated by the telephone company. Depending on this, UNI and NNI are further subdivided into public and private. Click Next to continue. Transmission paths, that is TPs, virtual paths, that is VPs, and virtual circuits, that is VCs, are used to establish connection between two endpoints. The physical connection between an endpoint and a switch or between two switches is known as a transmission path. In order to route data from one endpoint to another, the virtual connections need to be identified in a virtual circuit network. ATM network uses two identifiers such as Virtual Path Identifier, that is VPI, and Virtual Circuit Identifier, that is VCI. Click Next to continue. ATM architecture uses a reference model to describe the ATM functions. This reference model comprises of ATM layers and different planes that provide specific services. The planes in the ATM reference model are Control, generates and manages signaling requests. User, manages data transfer. Management, contains two components. Layer management, manages the layer-specific functions such as the detection of failures and the protocol problems. Plane management, manages and coordinates functions related to the complete system. The ATM reference model consists of the following ATM layers. Physical layer, manages the transmission that are dependent on the medium of propagation. ATM layer. This layer simultaneously shares the virtual circuit over a physical link and passes these cells through the ATM network. ATM adaptation layer, that is AAL. This layer isolates the higher layer protocols from the details of the ATM processes. This layer prepares the user data for conversion into cells and segments the data into 48-byte cell payloads. Click Next to continue. The Integrated Services Digital Network, that is ISDN, involves digital telephony and data transport services offered by the regional telephone carriers. ISDN is used in the high-speed image application, additional telephone lines in homes, high-speed file transfer, video conferencing, and voice service. Click Next. The customer premises equipment, that is CPE, in an ISDN network can be referred as the ISDN compatible devices which are connected to each other at the customer site. These devices include telephone, PC, telex, and facsimile. The ISDN network includes devices that connect a CPE and a network for transmitting information. The Integrated Services Digital Network, that is ISDN, consists of the following devices. Terminal Equipment Type 1, that is TE1. These are specialized ISDN terminals that support the ISDN standards and are connected to the ISDN network directly using a 4-wire twisted pair digital link. Terminal Equipment Type 2, that is TE2. These are non-ISDN devices that are not directly connected with an ISDN network but are connected to the ISDN network using a terminal adapter, that is TA. Terminal adapter TA. It converts information received in non-ISDN format from a TE2 device into a format capable of being carried by the ISDN. It can either be a standalone device or a board inside the TE2. Network termination devices. These connect the 4-wire subscriber wiring to the conventional 2-wire local loop. The network termination devices are of 3 types. Network termination type 1, that is NT1, network termination type 2, that is NT2, and NT1 or 2 device. ISDN specifies a number of reference points that define logical interfaces between the functional groups such as TE1 and 2, TAs, and NT1 and 2. The reference points are described as follows. R. It is the reference point between a non-ISDN equipment, TE2, and a TA. S. It is the reference point between user terminals, TE1 or TA, and the NT1 or NT2 if present. T. It is the reference point between NT2 and NT1 devices. U. It is the reference point between NT1 devices and line termination equipment in the carrier network. Click Next to continue. The information transmitted over the ISDN network travels through the 3 logical digital communication channels. Bearer, that is B channel, data, that is D channel, hybrid, that is H channel. The channels function as follows. B channel carries user service information that includes digital data, video, and voice. It is the basic user channel. Any type of digital information is carried in full duplex mode by this channel. This is done as long as the required transmission rate does not exceed 64 kbps. D channel carries signals and data between the user and the network. Carrying control signaling for the B channels is the main function of a D channel. Different control information are call establishment, ringing, call interrupt or synchronization, telemetry, and alarm transmission. H channel performs the same functions as that of the B channels and operates at data rate of 64 kbps. Click Next to continue. ISDN provides 2 types of user services. ISDN Basic Rate Interface Service, ISDN Primary Rate Interface Service. Click the various boxes to learn more. When done, click Next to continue. Broadband ISDN, that is BISDN, is an extension of ISDN. It can be used for technologies such as video conferencing and file transfer. Subscribers to the network are provided with a data rate in the range of 600 Mbps by BISDN. This data rate is almost 400 times faster than PRI rate. Click Next to continue. BISDN services can be broadly categorized into two types. Interactive services require two-way exchanges between either two subscribers or between a subscriber and a service provider. Distributed services, unidirectional services sent from a provider to subscribers without the subscriber having to transmit a request each time a service is desired. These services are further divided into various other services like conversational messaging and retrieval under interactive services, and no user control of presentation and user controlled presentation under distributed services. Click Next to continue. Fiber Distributed Data Interface, that is FDDI, is based on a ring topology and token passing. The data transfer rate of FDDI is 100 Mbps, which enables it to connect high-end devices such as mini computers and peripherals or high-performance devices in a LAN. Click Next to continue. FDDI is based on the dual ring topology, which has two counter-rotating rings. The data on each ring flow in opposite directions. Out of the two counter-rotating rings, one ring is the primary ring and the other is the secondary ring. The primary ring carries token and data. The secondary ring remains idle and is used as a backup for fault tolerance. Click Next to continue. Dual ring is a fault-tolerant feature in FDDI. The two counter-rotating rings in the FDDI network provide protection in case of node or a link failure in the network. If the cable is damaged, the nodes in the failed section loops back the data through the secondary ring. Hence, the dual ring is automatically wrapped into a single ring. The data continues to travel through the secondary ring during the wrap condition without affecting the performance of the device. If a device on the dual ring fails, the network is reconfigured dynamically and the failed device is isolated. The primary and the secondary rings are then wrapped onto each other to form a single one-way ring. Click Next to continue. A device that orbits around the Earth is called as a satellite. It is used for receiving and transmitting signals. Each satellite has a number of transponders. The signals are received by these transponders and bounce back to Earth. These signals are then received by any of the dish-shaped Earth stations and are then transmitted using cables, phone lines, or microwaves to the final receivers such as the TV set. Click Next to continue. Polling is a communication technique which determines when a terminal is ready to send data. The communication system comprises of a master station, number of slave stations, a two-way transmission line connecting the master station and the slave stations. The communication takes place in the following manner. Each slave station sends a request for communication to the master station. The master station detects this request for communication and memorizes the slave station from which the request is detected. This is done until an acknowledgement is sent to the slave station. The slave station then starts with the data transfer. The master station has a cyclic address pointer, which points to the address of the next slave station in a cyclic order. Click Next to continue. A simple communication scheme in which each transmitter or source in a network sends data whenever there is a frame to send is called as Aloha. The next frame is sent only if the first frame reaches the destination successfully. If the frame fails to reach the receiver, it is sent again. The two types of Aloha used are as follows: Pure Aloha, Slotted Aloha. Click Next to continue. In this lesson, you learn that WAN covers a large geographical area and consists of two or more LANs. WAN uses circuit, message, and packet switching technologies. PSTN uses copper wires to carry analog voice data. X.25 is a connection-oriented packet switching protocol. Frame Relay is a high-performance WAN protocol. frame relay operates at the physical and data link layers. ATM transmits data, voice, and video signals simultaneously. ISDN digitizes the telephone network to transmit information. FTDI is based on ring topology and token passing. Click Next to take a quiz. Welcome to the Configuring Network. Computers are connected together to form a network. By networking, you can achieve centralized and distributed processing. In centralized computing, database is stored in a server, which is generally a powerful mainframe and which provides services to the client machines. The client machines do not have processing power of their own. In distributed processing, the clients have processing power. Most of the processing is done by them, and the file server only stores and serves data. Click Next to continue. In this lesson, you will be able to understand client-server model, explain microwave, explain infrared, that is IR, understand electromagnet, that is EM, radiation and spectrum, explain remote access, explain VPN, explain internet connection sharing, that is ICS, understand connectionless internetworking, explain internetwork routing. Click Next. In the client-server model, the client generates data requests to the server. The server processes the request and provides the resultant data to the client. The data is then displayed by the client, which provides a user interface. Click Next to continue. The part of the electromagnetic spectrum corresponding to radio frequencies is called as radio frequency spectrum. It consists of different frequency bands such as ELF, SLF, ULF, VLF, LF, MF, HF, VHF, UHF, SHF, and EHF. Click the various boxes to learn more. When done, click Next to continue. Electronic devices that propagate different electromagnetic signals such as radio, television, or other telecommunications with the help of antennas are called as transmitters. A type of radio network that operates several transmitters on a single frequency is called as a single frequency network, that is SFN. In SFN, each station usually runs synchronously with the others to avoid interference. Click Next to continue. Spread spectrum is a system in which the transmitted signal is spread over a frequency band. This frequency band is much wider than the minimum bandwidth required for transmitting the information. The signals from different sources are combined together to fit into a larger bandwidth. Click Next to continue. Frequency hopping is a modulation technique used in spread spectrum transmission. In this technique, the frequencies are repeatedly switched between predetermined frequencies known as hops. According to the specified algorithm, which can be either random or pre-planned, a transmitter hops between available frequencies. The receiver remains tuned to the same center frequency as the transmitter. Data packets are transmitted on a narrow band. The transmitter changes the frequency and transmits again. Thus, the transmitter hops its frequency several times. Click Next to continue. The most common modulation technology is direct sequence, that is DS spread spectrum. In this technique, data is divided into smaller parts called chips. Different frequencies are used to transmit these chips. Dividing the data into chips enables the receiver to properly reassemble the data by providing information about the cycle of frequency changes. This technique is called spread encode. Click Next to continue. Although spread spectrum technology is extremely complex and expensive, it has a number of advantages. Click the various boxes to learn more about the benefits of spread spectrum. When done, click Next to continue. Electromagnetic waves with wavelengths longer than infrared light but shorter than radio waves are called microwaves. It has frequency ranging between 1 and 300 GHz. They are high-frequency radio waves. Microwave communication requires two types of antennas. Click Next to continue. Parabolic dish antenna is based on the geometry of a parabola. All lines intersect in a common point. This point is called as focus. Wide range of waves are caught by the parabolic dish and sent to a common point. Thus, it works as a funnel. This type of antenna is used for receiving only. Click Next to continue. In horn antenna, a stem is used which broadcasts the outgoing transmissions. A curved head then deflects these transmissions outwards in a series of narrow parallel beams. The received transmission are collected by the scooped shape of a horn and then deflected down into the stem. Click Next to continue. Infrared radiation is the electromagnetic radiation of a wavelength longer than that of visible light but shorter than that of radio waves. Infrared radiation is popularly known as heat or heat radiation. Infrared is divided into 3 parts. Click the various boxes to learn more. When done, click Next to continue. When energy travels through a material medium or through free space in the form of electromagnetic waves, it is called as electromagnetic, that is EM radiation. Radio waves, visible light, IR, ultraviolet radiation, X-rays, and gamma rays are all examples of EM. The distribution of the electromagnetic radiation according to the energy or according to the frequency or wavelength is called as the electromagnetic or EM spectrum. The figure shows the different regions in EM spectrum, their wavelengths, frequencies, and energy. Click Next to continue. Connecting the LANs in 2 buildings using lasers on their rooftops is the most modern application of light wave transmission. These lasers follow a unidirectional path. Thus, each building should have its own laser and its own photodetector. Click Next to continue. Communication established with a distant computer system or computer network is called as remote access. Remote access enables users to dial into a server at the business location and log into the network as if they were local to the user. In remote access, the remote computer becomes a host on the network. To connect to the network, a computer, a modem, or some remote access software is needed. Click Next to continue. Remote access clients can dial in from remote locations and access resources as if they are physically attached to the network. There are 4 types of remote access connectivity. Click the various boxes to learn more. When done, click Next to continue. To create a VPN client in Windows XP, select Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Click Create a new connection in the left. Click Next. Select the Connect to the network at my workplace option and click Next. Select the Virtual Private Network Connection option and click Next. Enter NIU in the company name text box and click Next. Enter vpn1.ess.niu.edu in the hostname or IP address text box and click Next. Select the appropriate option and click Next. Select the Add a shortcut to this connection to my desktop checkbox and click the Finish button. To create a dial-up network in Windows XP, open the Network Connection type screen, select the Connect to the Internet option and click Next. Select the Set up my connection manually option and click Next. Select the Connect using a dial-up modem option and click Next. Enter the name of the ISP provider in the ISP name text box and click Next. Enter the phone number in the phone number text box and click Next. Select the appropriate option and click Next. Enter the username in the username text box and password in the password and confirm password text boxes and click Next. Click the Finish button. A private communication link between 2 companies is called as a dedicated connection. It is a permanent connection and is always available for use as it is hired from the telephone company. It can be divided into 2 groups, such as dedicated private connections between 2 locations and the dedicated connections to the internet. A company uses a dedicated connection to reduce the telephone bill and to establish higher connection speeds than regular dial-up. Click Next to continue. The physical remote connection is not running. The physical remote access connection depends on the type of connection. Accordingly, there are many possibilities for the connection to not work properly. Follow these steps to troubleshoot this problem. Remote connection fails. Improper configuration can lead to remote connection failures. Configuration takes place at many levels. To ensure proper remote connection, you need to check the configuration. VPN is a private communication network provided over a public network such as Internet and is used within a company or organization. It uses a virtual connection instead of a dedicated connection such as a leased line. VPN extends the geographic connectivity, enhances security, reduces the transportation costs for remote users, improves the productivity, and simplifies the network topology. Click Next to continue. VPN uses various methods for keeping the connection and data secure. The different methods used for security are firewalls, encryption, IPsec, and AAA server. Click the various boxes to learn more. When done, click Next to continue. An entire LAN to the Internet using one Internet connection. A device which has a modem or broadband interface that establishes connection to the Internet is called ICS host. The devices that connect to the Internet through the network and the ICS hosts are called ICS clients. Click Next to continue. To achieve Internet connection sharing, ICS uses network address translation, that is NAT. It also has other components which help sharing the connection. Click the various boxes to learn more. When done, click Next to continue. To enable Internet connection sharing in Windows XP, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click Local Area Connection. Click the Properties button. Click the Advanced tab. Select the Allow other network users to connect through this computer's internet connection checkbox and click OK. To confirm the LAN adapter IP configuration in Windows XP, open the Local Area Connection Properties dialog box. From the This connection uses the following items list, click Internet Protocol, TCP/IP, and click the Properties button. Select the Obtain an IP address automatically option and click OK. To configure a client computer to use shared internet connection, open the Network and Internet Connections window and click Internet Options. Click the Connections tab. Click the Setup button. Click Next. Click Connect to the Internet and click Next. Select the Set up my connection manually option and click Next. Select the Connect using a broadband connection that is always on option and click Next. Click the Finish button. ICS was first launched with Windows 98 SE, and with the launch of Windows XP, it has become better. ICS allows different computers on the LAN to perform different tasks simultaneously. For example, browsing the internet on one, sending and receiving email messages, and downloading a file on another. Click Next to continue. Transfer rate is slower than the typical rate of the medium. If a high bandwidth connection to the internet is used by an ICS, the transfer rate may be slower than the medium's typical rate. Click Next to continue. Individual local area networks, that is LANs, are connected together to create a wide area network, that is WAN, is called internetworking. In the figure, there are many computer terminals, that is end systems. A router, which is an intermediate system, is placed between the end systems. The connection between the router and the end system is termed as a network, whereas the connection between the two end systems is called as an internetwork. Click Next to continue. Internetworking involves connecting networks that use different protocols, and thus it can be extremely complex. Internetworking is achieved using the following devices. Click the images to learn more. Click Next to continue. In connectionless internetworking, data can be sent without any need to establish a connection first. Thus, there is no guarantee of delivery of data. In the figure, there are two computer terminals, source and destination. And there are three different networks, each having different computers. The packets are sent through the internetworking devices such as routers from the source to the destination. Whenever the source computer wants to send packets, they should pass through any of the networks before reaching the destination computer. Click Next to continue. Connectionless Network Protocol, that is CLNP, is an ISO network layer datagram protocol. It is similar to the Internet Protocol, that is IP, and provides the same underlying service to the transport layer as IP in the TCP/IP environment. Click Next to continue. Internetwork routing is a process of forwarding data packets from a source to a destination on different networks by using routers. There are different types of routing protocols used for routing. Click the various boxes to learn more. When done, click Next to continue. The process of transferring data across an internetwork from a source host to a destination host is called as routing. Two processes involved in routing are host routing, router routing. Click Next to continue. When the sending host forwards a packet, host routing is said to occur. The sending host has to decide whether it should forward the packet to the destination or to a router. This is decided depending on the destination network address. In the figure, the local host and the source host are on the same network. The remote host is on the other network. There is a router between the source host and the remote host. The packet passing from the source host to the local host is called as direct delivery. The packet passing from the source host to the remote host through router is called as indirect delivery. Click Next to continue. When a router receives a packet which is to be forwarded, router routing is said to occur. The packet is forwarded between routers or between a router and the destination host, depending upon the connectivity of the destination network to the router. In the figure, there are two routers and a destination host. Click Next to continue. The entire structure of the routed internetwork is called as the routing infrastructure. There are different routing infrastructures. Click the various boxes to learn more. When done, click Next to continue. In this lesson, you learn that in centralized processing, processing is done in a single computer. In distributed processing, processing is done in more than one computer. Client-server is a combination of centralized and distributed processing. RF is wireless communication technology which uses electromagnetic waves. SFN operates several transmitters on a single frequency. Click Next to continue. In this lesson, you learn that remote access is communication established with a distant computer. In ICS, multiple computers connect to internet through single connection. Creation of WANs by connecting individual LANs is called internetworking. Router is a device that forwards data packets towards its destination. Routing is a process of transferring data across an internetwork. Click Next to take a quiz. Welcome to the Configuring Networks lab. Here you will learn about network servers,
Welcome to the Security and Network Management Lab. Here, you will learn about network security, protocols, and about testing and troubleshooting networks. Network security includes techniques like cryptography, digital signatures, authentication protocols, and firewall to enhance the security of the network. Click on a topic on the screen to continue. Anything that prevents users from accessing the required resources for performing their task is known as a threat. Threats not only include hacking, but they also include bad configuration, viruses, and unintentional corruption of data. Threats are classified into two groups: internal and external threats. Internal threats are wrong practices done by users in the network, resulting in inefficient working of the network. Whereas in external threats, a user outside the network gains access to the internal network, trying to get or damage the data. Click Next to continue. In this lesson, you will be able to explain the need for network security, discuss the objectives of cryptography, explain the concept of digital signatures, identify the different authentication protocols, explain the concept of firewall, discuss the concept of VLAN, explain the various fault-tolerant and redundancy methods, list the different network security protocols. Click Next to continue. Attacks intended to harm the security of a network are called security attacks. They break the security barrier of the network and access network resources. There are two types of security attacks carried on a network: passive attack, active attack. Click the various boxes to learn more. When done, click Next to continue. The other types of attacks that are carried over a network are denial of service, that is DOS, virus attacks, password cracking, domain name server, that is DNS, spoofing, and IP spoofing. Click the various boxes to learn more. When done, click Next to continue. It is necessary to implement external network security. Basically, there are three types of setups: home system connected to the internet, a small office network, and a large organizational network. Click the various boxes to learn more. When done, click Next to continue. Cryptography is a science that deals with securing information. It mainly deals with securing information that is stored in the system or transferring data over a particular medium. Cryptography involves securing of messages, authentication, and digital signatures. It also includes encryption and decryption. Click Next to continue. When the message is transmitted over the network, the message is encrypted so that no other person can read it. At the receiving end, the user may require special software to decrypt the message. Encryption refers to conversion of plain text into ciphertext. Ciphertext is a coded set of data that is not accessible without a key. The cipher algorithm is used to transform plain text into ciphertext. Encryption is performed using special keys. Only the sender and the receiver of the information know the key. Decryption means converting the ciphertext back to plain text. The same cipher algorithms are used for decrypting. Click Next to continue. Public key encryption and decryption uses a combination of two keys, private and public. The private key is known only to the receiver of the message. The public key is available to any person who wants to send the message. When user A wants to send information, he uses B's public key to encrypt the message. At the receiver's end, B decrypts the message using the B's private key. This ensures that the message can only be decrypted by its intended recipient. The public key and the private keys are never the same. Click Next to continue. Secret key encryption and decryption uses the same key to encrypt and decrypt the message. The private key is shared between the sender and receiver. The algorithm used for decrypting the message is the inverse of the algorithm that is used to encrypt the message. Click Next to continue. Digital signatures are used to authenticate the origin of the document. It helps us to know the details of the sender of the document. These signatures also check the integrity of the document. Using signatures, the user can come to know whether the content of the document was altered by any other unauthorized person. Digital signatures use public-private key cryptography. Private key is used to encrypt the message and public key is used to decrypt the message. Digital signatures can be accomplished in two ways: signing a document, signing a digest of the document. Click Next to continue. Signing a document involves encryption of the document with the private key of the sender. The document is then decrypted at the receiver's end with the help of a public key given by the sender. Click Next to continue. In signing the digest, digital signature uses hashing function to get a message digest. The hash algorithm creates a digital representation of the information. At the receiver's end, a new hash value is generated for the message that is received. Then, both the hash values are compared at the user's end. Using the public key of the sender, obtained from the Key Distribution Center, that is, KDC, the receiver's software checks whether the document was signed using the sender's private key. If both the keys match, the receiver understands that the message was signed by the sender and was not altered by any other person. This ensures the data integrity of the message. Click Next to continue. Authentication is a process by which the identity of a person who wants to communicate is identified before starting the communication process. There are various techniques and protocols used for authentication purpose. Each technique has its own advantages and disadvantages. Click Next to continue. For explaining the authentication based on a shared secret key, consider two users, A and B. They share a secret key represented by KAB. First, A sends his identity A to B. B chooses a random number, RB, and sends it back to A as a plain text message. This is a challenge from B to A. Such random numbers are known as nonces. A then encrypts the message using the shared secret key and sends the cipher text KABRB. B sees this message and understands the message is from A as A had the secret key. B knows he is talking to A, but A does not know that he is talking to B. So, A sends a random number RA as plain text message. B responds by sending cipher text KABRA, which gives A the confirmation that he is talking to B. Click Next to continue. Kerberos is an authentication protocol which is present in operating systems such as Windows 2000. It was designed at Massachusetts Institute of Technology and has different versions. Version 4 is the most popular version. There are 3 types of servers involved: Authentication Server, Ticket Granting Server, Real Server. Authentication Server, that is AS. Each user is registered with the AS and is granted a user identity and password. AS has a database of the identities and their respective passwords. AS verifies the user, provides session keys to be used between the users and Ticket Granting Server, that is TGS, and sends a ticket for TGS. Ticket Granting Server, that is TGS. TGS issues a ticket for the real server. It also provides the session key between the two users. In Kerberos, ticket issuing is different from user verification. This allows users who have verified the ID with the AS once can contact the TGS again for obtaining tickets for different real servers. Real Server. Real Server provides different services for the user. Kerberos is designed for client-server programs such as FTP, where the user uses the client process for accessing the server process. Kerberos is not used for person-to-person authentication. Click Next to continue. The following process takes place between the different servers. A requests ticket for TGS. AS sends A TGS session key and ticket for TGS. A requests ticket for B from the TGS. TGS sends AB session key and a ticket for B. A requests access to B. B grants access to A. Click Next. In public key cryptography, both the members need a shared symmetric key to initiate communication. If A wants to send a message to B, it only needs to know B's public key, which is known to everyone. As everyone knows the public key, this method is also not secure. So, certification authority, that is CA, is used as a more secured approach. CA is a federal or state organization that binds a public key to an entity and issues a certificate. CA has a strong public key that cannot be forged. Suppose B wants to secure his public keys, the CA first checks B's identification. It then asks for B's public key and it stores on its directory. CA then writes it on a certificate and signs the certificate using the CA's private key. B can now upload the signed certificate. Anyone who needs B's public key needs to download the signed certificate and use the public key of the CA for extracting B's public keys. Click Next to continue. Which server provides services for the users in Kerberos authentication protocol? Select the correct answer and click Submit. Firewall is a system that blocks all unwanted and unauthorized access of system resources. Firewalls are designed for forwarding the desired packets and filter the packets which are not required. A firewall is present at the junction point between two networks such as a private and public network. Click Next to continue. There are two basic types of firewalls: packet filter firewalls and proxy firewalls. Click the various boxes to learn more. When done, click Next to continue. To enable the firewall in Windows XP, select Start. Select Control Panel. Click Security Center. Click Windows Firewall. Select the On option. Click OK. A demilitarized zone, that is DMZ, is a lightly protected network that is usually present between the firewall and the external network of an organization, that is Internet. In the DMZ, connections from the internal networks and the external networks to the DMZ are allowed. However, connection from the DMZ to the external network is permitted, but not permitted to the internal networks. Thus, the internal network is protected from external attacks. Click Next to continue. A virtual local area network, that is VLAN, is a switched network that is logically segmented on an organizational basis with respect to functions, project teams, or applications, and not on a physical or geographical basis. The figure shows the concept of a VLAN. Any station can be moved logically from one VLAN to another. All the members belonging to a particular VLAN can receive broadcast messages sent to that particular VLAN. If a particular system moves from VLAN 1 to VLAN 2, it will receive broadcast messages sent to VLAN 2, but not which are sent to VLAN 1. Click Next to continue. After establishing a VLAN, you need to configure the VLAN. The stations in a VLAN can be configured in three ways: manual, semi-automatic, and automatic. Click the various boxes to learn more. When done, the loss of shared data in a network is a great concern. Care should be taken to protect a server containing the shared data. Capability of a server to continue operating even in case of a hardware failure is known as fault tolerance. To implement fault tolerance, the data should be made redundant on the serving system so that the system would create a copy of the data on another device. There are various techniques to make the data redundant. Click Next to continue. Random Array of Inexpensive Disks, that is RAID, is a technology that uses a collection of hard disks to share and replicate the data. The operating system recognizes multiple hard drives as a single logical unit. RAID is performed on multiple hard drives of identical sizes. The different levels of RAID are RAID 0, 1, 2, 3, 4, 5, 6, 0 plus 1, 10, 53, and linear RAID. Click Next to continue. Network Attached Storage, that is NAS, is used for implementing a server for file sharing. It is a single system running an operating system and has a NIC and uses the TCP/IP protocol. NAS runs Network File System, that is NFS, or Linux with Samba to allow other systems to access the shared folders. The NAS is a server without programs that is available on the normal servers. It is configured through programs that run from another system or a web interface because it does not have a keyboard or a monitor. Click Next to continue. Storage Area Network, that is SAN, is a network whose primary aim is to transfer data between computer storage devices like disk arrays, tape drives, and servers. It is a group of computers connected to an array of hard drives using an advanced serial technology like the fiber channel technology. Fiber channel allows hot swapping of drives, RAID, and cable distances of up to 30 meters between a device and a host bus adapter, that is HBA. Hot swapping involves changing the bat drive without having to restart the server. Click Next to continue. Tape backup is used to back up the server data completely. A magnetic tape is used to store the data. The backup method and the type of tape used vary from network to network. The tape backup options are classified into groups: quarter-inch tape, that is QIC, digital audio tape, that is DAT, and digital linear tape, that is DLT. All the groups use cartridge tapes, but they differ in the physical cartridge size, capacity, recording technique, length of the tape, and speed. Tape backup can also back up the data in a compressed format. Click Next to continue. The system that is going to be connected to the network has 4 main functions. It should be connected via a cable or a wireless connection. The shared data should have more than one copy. The shared data should be available as fast as possible. The system should be reliable. Click Next to continue. The server has to handle many transactions at a given time while providing access to shared resources to other computers. Systems that share resources require faster hardware to respond to the network needs. The 2 things that can make the server provide good speed are fast NICs, fast drives. Click Next to continue. Reliability means methods that would make sure the system does not stop working in case of a failed component. Reliability can be achieved by providing a secure environment for the server and providing redundant hardware components for the server in case of component failure. A few methods to improve reliability are good power. A steady AC power supply is to be provided to all the systems. The different power problems are overloading, power outages, electrical spikes, and overloaded circuits. The server can be protected from these problems by using dedicated circuits, surge suppressors, UPS, and backup power. Computer virus. Whenever a virus infects a computer, it becomes slow or generates errors. Either a virus makes more copies of itself or it is activated at a particular time and date causing damage. There are 5 typical types of viruses: boot sector, executable, macro, Trojan, and worm. Antivirus programs. The antivirus program scans the computer's boot sectors and files for viruses. If it finds any viruses, it asks the user whether to quarantine or remove the infected file. It passively monitors the computer's activity and checks for viruses when a file is being downloaded or a program is being executed. Virus prevention tips. It is better to use an antivirus shield that automatically scans floppies and downloaded files. It is also necessary to scan the system daily for virus attacks. It is necessary to check all the removable media that was exposed to the system and any other machine that may be affected by a virus attack. Environment. It is necessary to provide a good environment for the server for reliability. Lock the server room all the time to prevent any unauthorized access. Keep the humidity in the server room low. 40% is right for electronic components. Maintain a temperature of around 22 degrees Celsius. Click Next to continue. Different types of protocols are used at different layers of the OSI model for providing security to the users, which are Serial Line Interface Protocol, that is SLIP, Point-to-Point Protocol, that is PPP, Point-to-Point Tunneling Protocol, that is PPTP, Internet Protocol Security, that is IPsec, and Secure Socket Layer, that is SSL. Click the various boxes to learn more. When done, click Next to continue. In this lesson, you learned that there are two types of threats, internal and external threats. Cryptography involves encryption and decryption to safeguard data. Digital signatures involve the use of private and public keys. Authentication involves verification before starting communication. Encryption refers to conversion of plain text into ciphertext. Decryption means converting the ciphertext back to plain text. Click Next to continue. In this lesson, you learned that firewall blocks unwanted and unauthorized access to system resources. Demilitarized zone is usually present between the firewall and internet. VLAN is a switch network logically segmented on an organizational basis. RAID uses different techniques of using multiple drives for data protection. Network-attached storage is used to implement a file-sharing server. SAN is used to transfer data between storage devices and computers. Tape backup is essential in case of hardware or server crash. Click Next to continue. In this lesson, you learned that SSL is designed to provide security and compression services to data. IPsec provides security to a packet at the network level. PPTP allows secure data transfer from a remote client to a private server. Point-to-point protocol, that is PPP, is used for point-to-point access. SLIP is used to send IP datagrams between serially connected devices. Click Next to take a quiz. Welcome to the secure. Data transmitted within a network travels through various physical devices and finally reaches the intended destination. If any device on the transmission path is not working, the data will not be transmitted. Various testing and troubleshooting tools are available to keep the network functioning. Click Next to continue. In this lesson, you will be able to identify the tools used for troubleshooting physical networks, perform loopback tests, explain the various diagnostic utilities, troubleshoot TCP/IP connections. Click Next to continue. The software tools analyze the network and trace any problems present in the network. Software tools make the task of troubleshooting networks easier. Mostly, these tools are available with the operating system, for example, Windows Network Monitor and Hyper-Terminal. Click Next to. In loopback testing, a signal is transmitted and is echoed back to the sending device after the signal has traversed all or a portion of a network or circuit. The echoed signal is compared with the signal that was transmitted. This is used to evaluate the integrity of the equipment or transmission path. A loopback plug is required to perform a loopback test. Loopback plug is inserted into a port. A loopback test can be used to verify that RS-232 communication hardware is working. It can also test a radio interface and computer's serial port. DCE devices have a loopback capability which can be used for testing. DCE devices are modems, multiplexers, and routers, hubs, switches, and access server. When this option is enabled on the DCE device, signals instead of being sent to the receiver are reflected back to the sender. Click Next to continue. To perform the loopback test using Hyper-Terminal, click Start. Select all programs. Select Accessories. Select Communications. Click Hyperterminal. Enter a name, choose an icon for the connection and click OK. Select the appropriate COM port from the Connect Using drop-down list and click OK. Select the None option from the Flow Control drop-down list and click OK. Enter any text. If the serial port is working and the loopback plug is properly connected, the text you type appears in the window. This indicates that the serial port is working. Click Close. Network Monitor is used to view and detect problems on local area networks. It gathers information from the network traffic, which is divided into frames. The frames contain the address of the sender computer, the address of the receiver computer, and the protocols present in the frame. The data that is captured by the network monitor can then be used for analysis by the administrator. Click Next to continue. At times, the problem in the network may be physical, such as a cable break, improper cable connection, or a fault in the network devices. You need to perform various tests on the cables and the devices used for communication to identify the problem source. Click each image to learn about the hardware tools. Click Next to continue. Troubleshooting is a process which requires making instant judgments and acting on them in order to fix the network problem. It is not possible to list all the problems that may occur in a network, and there are no fixed set of steps that are followed to troubleshoot a problem. Click Next to continue. Troubleshooting can be simplified by breaking it into simple steps even if the problem is very complex. The sequence of steps makes the task of resolving a problem simple and very easy. The steps shown alongside must be followed to resolve network problem. Click Next to continue. Troubleshooters use the 4-layer model to fix network problems. This model focuses on components such as hardware and software which make a networking system function. This model helps you to access, change, remove, install, troubleshoot, and fix every layer. The layers include hardware, protocols, network, shared resources. Click Next to continue. The important question during installing and troubleshooting a network is to know the quality of the cables. To diagnose the problems related to the network cables, cable testers are used. Click each box to learn about the features of cable testers. Click Next to continue. Click each box to learn about some more features of cable testers. Click Next to continue. Connectivity problem occurs when the stations cannot communicate with each other within a LAN or WAN. There are different causes for network connectivity problems, which are as follows: faulty network adapters, wrong switch configuration, faulty hardware, driver issues, upgradation of operating system, server relocation, network adapter is incompatible with the motherboard or other hardware or software components and drivers. Click Next to continue. Address resolution or connectivity may not work if there are some problems in packet filtering. TCP/IP packet filtering should be turned off in order to determine whether the network problem is caused due to packet filtering. To verify packet filtering, click Start. Click Control Panel. Click Network and Internet Connections. Click Network Connections. Double-click the local area connection. Select the Internet Protocol TCP. Click the Advanced. Click the Options. Select TCP/IP filtering and click the Properties button. Clear the Enable. Network troubleshooting involves the technician to have the correct attitude, patience, and desire to constantly educate themselves about the network. Most of the networking problems occur at the physical layer of the OSI model and include problems with cables, connectors, and NICs. Click Next to continue. Various commands are provided by the OS which help you to troubleshoot many network-related problems. At times, These commands are enough to resolve your problems. You may not require any third-party tools. Click each box to learn about the various diagnostic utilities. Click Next to continue. To use the ipconfig command line tool, select Start and click Run. In the Run dialog box, enter CMD. Then, in the command prompt, type ipconfig. Click Next to continue. The methods employed to troubleshoot different TCP/IP network connectivity problems depend on the type of network and the problem. The user can troubleshoot TCP/IP connections manually as well as automatically. Click Next to continue. To manually troubleshoot TCP/IP, follow the steps shown in the image alongside. Click Next to continue. Click Next to continue. The TCP/IP connection can be automatically troubleshooted by using the Network Diagnostics tool, which is provided by Windows XP. To troubleshoot TCP/IP using Network Diagnostics, select Start. Click Help and Support. Click Use Tools to view your computer information and diagnose problems. From the left pane, click Network Diagnostics. Click Scan your system. If any item is marked Failed in red, expand and view that category for any extra information. Click Close. In this lesson, you learned that loopback test is used to test if the ports are functioning properly. Faults in cables can be located using time domain reflectometer. Network monitor provides information related to network traffic. Protocol analyzers interpret the contents of the intercepted packets. NetStat is used to check the ports that are active on your system. ipconfig provides information related to TCP/IP connection. ipconfig is used for Windows 2000 or later versions. WinIPCFG is used for Windows 98 or other Win9X versions. ARP links IP address of node to its physical address. Click Next